Looks like all systems go. We have sound, we have video, and it's Tuesday, so all the factors are here. Hi everybody, and welcome to the Keshe Plasma Reactor Group for Tuesday, March 7th, 2017. And I see I have a glaring light in the background. Let me phase that another direction. And yeah, so my name's Rick Crammond, and I'm your host, and we'll just dive into all kinds of topics here tonight. Who knows what will come up? And if who knew, then they wouldn't even tell us anyways, whoever who is. We don't have, what's notable today is we don't have Lee Coates to start things off. So we'll have to put up with other things. I've been playing with this little device here, which is basically a 500 milliliter flask of distilled water. We have that sitting on top of a treble speaker that looks like this. Tweeter. A titanium bullet tweeter. Well, this one wasn't quite as titanium as I thought it would be, and it promptly burned out after the first half hour of playing around with it. So I still have its twin over here that's mounted inside of this piece of tubing here. You see, I just lost my little special O-ring. I've got a little rubber O-ring that fits on there so that when the flask sits on it doesn't go metal on glass. And I've been experimenting with this, running it through amplifier here, and the amplifier is hooked up to my, whoops, I'm getting an echo in live stream. Sorry about that, live stream. I have to hook up my headphones properly here. Did that last week too. I think it's only when other people are speaking that I get the echo. In any case, it should be fine now. And so yeah, it's hooked up to an amplifier, and the amplifier was hooked up to my sound system, and I put different frequencies through into this little tweeter here, and this is able to go up to 24,000 hertz, and my sound system can go up to that much as well. So I put in anywhere from, this has a minimum of 4,000 hertz, so I experiment from 4,000 to 24,000 hertz. Mostly interested in somewhere around the 12 to 16,000 hertz, which should be the resonant frequency of this 500 milliliter flask. In which case, I've been looking. I use this little pipette here to put bubbles in and just squirt. Do a squirt like that. Puts little micro bubbles inside, and then I use my magnifying visor to peer inside and bombard it with ultrasonic sound, essentially. I haven't had any results yet, and I think I have to go with something more like a transducer, like one of these little babies here, and actually I'll actually have to glue it onto the sides of the on the side of the container. Probably two, or perhaps even an array of three or four could work. These guys are kind of small, so I'm not sure if I'll get the proper effect out of them. I might have to go to a larger transducer. And what I'm trying to do with all this, by the way, if you haven't followed the last 3 weeks of this class, is I'm working with the idea of sonoluminescence, which is producing light from sound. And the way it happens is you trap a little bubble in the center of the globe that's resonating, and you can actually get the bubble to sort of resonate back and forth, and with the right frequency it will actually give off light. It gives off heat as well, but only on a micro level. It can go up into the millions of degrees, and actually they've measured it up into the tens of thousands of degrees, but theoretically it's easily able to go into the millions and actually create fusion events at the micro level. And that's what I'm interested in. I want to make fusion in the center of this globe, and if we can create a little tiny wee fusion reactor there, then we can add different components to it. This could be GANS water of a certain type, and if we want to add that particular element into the mix, or the energy levels of that element, then during that fusion event perhaps we can create other kinds of materials. For example, if hydrogen was added, you could basically create alchemy and transform a substance into the next higher or lower level, and so on. So that's part of what I'm doing there. And so far I've burned out this top of the line 350 watt tweeter here. I made a mistake with that and didn't have the capacitor hooked up in line with it, and I think I gave it too much power, so I burned it out. But it does have a nice magnet to play with, so I did get that out of it. Otherwise it's tiny little coils, and I do mean tiny. If you look at the wire in there, it is so tiny that I'm surprised that any power at all would blow it out. It's anyway, this is part of experimenting. It's been an expensive week. Tweeters, and I also blew a battery charger for my remote controlled motor system that's behind me here, this little guy, and so he took a blow too, and there was some stinky smoke that the thing let out, and I had to let it out and put it out on the deck because it was stinking and smoking. So things happen here. It's been, like I say, an expensive week. Anyways, is there any questions about that setup, or shall we just move along here into some other topics?
That's beyond me. The one thing that does come to mind when I'm thinking about that, when you're talking about putting the transducers on the outside of the glass, would the mass of the glass interfere? Because you're dealing with extremely low energy levels with the high frequency. And even though you're pumping like lots of watts into it, the actual mechanical energy of that is actually quite low. So I'm wondering if
Right.
the glass is going to cause an issue.
Right. Well, it's actually not the mechanical energy so much that we need, is, even though it is actual mechanical in terms of this transducer, when it's glued on there, you want to have a hard glue, not a rubbery glue, so it sticks really closely to the glass surface. And it would be preferable probably to have a thinner glass so that it wouldn't absorb so much of the radiation coming off. But what we're actually looking for is it's more or less a wave. It's a waveform actually. It's like we want a standing wave to where the two waves come together, and it'll be node points and amplitude points and so on. And we want that centered according to the resonance of the it's not just the resonance of the sphere itself, it's the resonance of the water as a sphere. So if that was air inside, it would be a different resonating frequency. It'd be more it would just be different. So it's the vibration as well as the sound, I guess.
Well, sound is a vibration. It's like a pressure wave. So
Yeah.
you are transferring that mechanical energy through the glass. I was thinking something really thin, like a thin latex, instead of the
Well,
glass.
yeah, I was also, I have these kind of spheres too, right? Which they're quite thin. They're plastic. You can push into them and so on. Getting an echo through your microphone there, John. Um, yeah, so it's much thinner, but on the other hand, I'm not sure if it would transfer as well as the glass. Because when you think about it, if you have a plastic cup, a plastic wine cup, and you go ping, it goes like thud, thud. But if you have a glass wine cup, it'll go ping, ping. It'll have a higher natural resonant frequency, I think, with the glass itself. But
You ever
when
held a balloon up in front of a speaker?
a balloon up in front of a speaker, I don't know
They
if I
transfer
have.
they transfer that mechanical energy like mad. And if you hold a balloon up in front of a speaker, it'll actually vibrate so much it'll put your fingers to sleep.
Maybe you could have a vibrating bed that way for people that are having trouble sleeping. A water bed, maybe, with a vibration system in it.
Yeah, it's just the thing I'm thinking about with this experiment is you've got a lot of mass to move. And yes, you're looking for resonant frequency. And once you hit that frequency, then the mass isn't nearly as critical. But up to that point, I think you're going to want as little mass as possible to try to move.
Possibly, but it seems like the glass itself hasn't been part of the issues as far as the lab tests go that I've seen. People have asked, can I use this kind of glass? It doesn't really matter, just a lab flask of this size and so on. Most of the time they're using 100 milliliter rather than this 500 milliliter, so that could be an issue. A 500 milliliter has a much lower resonant frequency. For example, a 1,000 milliliter flask has about a 1100 kilohertz resonant frequency. I wasn't able to find the one for 500. I have to actually calculate it, but somehow somewhere between 1100 and 1800, probably around mid-range between them. So,
Rick,
mm-hmm.
this is John, another John here. We're three Johns today.
Holy
Uh,
cow! I see
you
that.
could
Three out of
try,
five. Three out of the five people here are Johns. Okay, go ahead,
yeah,
John number three.
you could use a light bulb, which has a very thin crystal or crystal side.
Yeah, the trouble is with very thin and glass and vibrating it is if you hit the resonant frequency, then that's a good thing, but it's a bad thing because that's when it'll actually start to vibrate and shatter. So the thing about it is they're not trying to vibrate just the glass. It's not the shell. It's the vibration of the water itself that's the important part, and that those vibrations are transferred inside. They may be able to pass through glass fairly easily. I'm not sure how ultrasonic works when it's right next to the glass, whether it will pass through easily or it actually vibrates the glass in order to attain the effect. Some people have tried to use the transducer away from the glass, and they had a hard time getting it to work. It works much better when attached directly to the glass, which is one of the reasons I'm having trouble with this setup. In spite of its high wattage and so on, and it turns out all it takes is about 1 watt of actual energy to create the sonoluminescence inside. It may require 30 to 300 watts to achieve that, depending on the efficiency of the system you're using. Um, there's
What
different
you
ways
could
to make it
try,
more. Mm-hmm.
what you would try instead of a round globe would be a cube. The sides would be a plane, so that would be much easier to make it vibrate than something which has a spherical surface.
Yeah, I don't think a cube would work though because seems like it has too many planes somehow. It wouldn't all focus toward the center. The planes would vibrate and have like a field more like this rather than all focusing toward the center. The idea is it all focuses toward the center, and that's where that null point will be that will start working on the bubble and so on. The thing about this is it's an exact frequency. It's not, it has to be hit exactly. I've got a frequency sweep generator that's online, and you can use it to go like up and down. Of course, you can't hear it; it's ultrasonic, but it tells you it's going up and down the frequency spectrum. The thing about it is, the key to all this is you need to use a transducer like this as also a microphone. So you hook this up to either an oscilloscope or some sort of a transducing back down system, so you can actually see what the frequency is of. You can tell when there's peaks in the frequency spectrum, and that's when this is resonating. So you do a sweep from maybe 10,000 to 20,000 hertz, and where this starts peaking, and maybe at 12,500 hertz, suddenly there's a peak in the spectrum. That'll be one of the resonating frequencies of this particular arrangement, which includes the glass, the water, the whole sphere resonating. And once you know that peak from this, picking it up, then you can tune in your transducers to exactly that peak and give them the most energy at that exact frequency. And you can alter the frequency, and you can actually watch the bubble. It'll oscillate quickly until you zone it in, then it starts to stop oscillating, and at a certain point the bubble will actually disappear. It dissolves into the water. So it's only a certain range of both frequency and the amplitude. The amplitude's important. Too much amplitude and the bubble disappears, and not enough and the bubble doesn't appear. So it's a tricky business, but they do have it nailed down as far as the specifications. It's just I have to follow the specifications instead of trying to do it my way with treble speakers and so on, instead of the proper transducers, which I don't really have yet. But this will probably work good as a pickup transducer. I don't know if it has enough power as a power transducer yet. I'll probably have to burn out a couple to find out. I'm pretty good at that. Anyway, any more about that? John says about all the Johns, we are so infamous that no matter where we go, there's already a room named for us. Johns. Little bathroom humor there.
Well, if every place needs more than one John, that's just a given.
That's true, and nowadays you need 3 of them because there's women, men, and in-betweens, or others, I guess you might say, ones that don't feel they fit into either one of those categories, or don't feel they'll be accepted in one of those categories, one or the other. In any case, they're pushing for both 3 bathrooms in some places in North America, and they're pushing for 1 bathroom and getting rid of all the designations in other places. So it's a battle of the bathrooms going on. All right, Dimitri, maybe you'd like to talk about your situation there. You were bringing up before we started broadcasting today.
Okay, thank you. It was just a quick question, because I've started to nanocoat some copper plates and some zinc plates as well. How at the moment I've just got it. I'm using a cold caustic method. I haven't begun to steam it in any way. After speaking to a few people, I was under the impression that a cold caustic for a long time would produce a structure of nanocoating that is not better, but is more is going to be more along the lines of what I'm going to be needing in terms of production of GANs. I was just hoping that someone could maybe uh, enlighten me a little bit on the different structures that are created by different temperatures of caustic nanocoating.
I think I can probably jump in here. As the temperature increases, the texture of your nano coating reduces. The higher the temperature, the finer structure you have in your coating. And if you use or if you coat the way I do, which I use a range of temperatures. Overnight, it's room temperature. During the day, I go between 150 and 180 or 190 degrees Fahrenheit, about 90 degrees Celsius.
Just launch into to what Dimitri and John are talking about here. Let's just recap what that was about, your conversation there. And it's regarding nano coating. Dimitri, if you can lay out your question there again, the way you did before, that would be
Yes,
useful.
of course. My question was, how does the temperature when you nanocoat using caustic affect the structure of it?
When you use a high temperature in your nano coating, what we're seeing is a very fine structure within the coating itself. The electromicrographs that we saw, which I wish I could find again, if somebody has them, please post them. The caustic coating looked like a city. It had crystal structures that were all different sizes and cracks and roads, and it looked like an aerial view of a city. The fire coating, the high temperature coating that they did, looked more like you were looking at a beach. Very fine structure. If we expand on this with the temperatures of the caustic coating, it would be reasonable to assume that a high temperature caustic coating is going to have a finer structure than a low temperature caustic coating. The crystals will grow quicker. There'll be more of them. It just makes sense that way. Now, you had mentioned that you had a specific purpose for your coating. And certainly, if you have a specific purpose for your coating, then you would want to tailor your process for that purpose. With a finer coating, I know this is incorrect way of describing this, but this is the only way I can think about it. With a finer coating, you have a higher frequency of plasma. You're not going to have the same range that you would if you had a combination coating, if you had both the fine and the coarse structure within your coating. So if that's what you're looking for, then awesome. Most of the systems we're working with right now, we want as broad a bandwidth of this plasma as we can get our hands on. For the energy devices, the health devices, not so much, because we're beginning to tailor them for very specific conditions. So we're looking for very specific GANs mixes, specific functions in the nano coating itself. And I think over time, what we're going to find is we can tune the nano coating for our, whatever condition that we're doing. What specifically are you working with that you're looking to tailor your coating to?
These plates will be used for my first run of GANs.
Okay, so you want
a
as
broad
broad a spectrum as
spectrum.
you can. Yeah.
Yes. Yeah.
So
Okay.
the way I do my coating, which is this is generated over a number of people's perspectives and a whole bunch of experience, is I use heat when I do my caustic coating, and I do it in a stainless steel electric frying pan. I used to do it in, the standard Armin method where you put it in a rack in a plastic thing, pour boiling water in, and just let it sit. That works fine. Like there's nothing wrong with that. But the way I have progressed into my coating is I'll do it in my electric fry pan over about a week, 7 to 10 days, and I vary the temperature during the day. During the day when I'm up and I'm watching it and I can add more water as it boils off, I'll keep the temperature up. I'll keep it, 60 to 95 degrees Celsius, 150 to 190 degrees Fahrenheit, which is not quite boiling, but it's enough to keep the steam, the vapor very, very high in that chamber. And then at night, I just turn it off, let it go down to room temperature, let everything settle really, really well. And the last run of coating that I just did a set of coils for a project that I'm working on for the Arizona factory. And these coils are the blackest, most awesome looking coating I have ever made in my life. And that was a varied temperature over an extended period of time.
Okay.
Now, again, we can't say that's the best way to do it. It's probably not the best way to do it, but with the information we have now, if you want to what I call a broad spectrum nano coating, which will take many different strengths of plasma within it and transfer that plasma, then you want a varied process in your system. You want a little bit of cold, a little bit of heat, lots of time. And it doesn't matter which coating method you use. You need lots of time. You need extend your time. You're going to get a better coating.
Yeah. Awesome. Thank you very much.
I know it wasn't one sec. I know it wasn't a great explanation, but it's about all we have right now.
Thank you.
Okay.
Yeah. John,
Go ahead.
how do you replenish your water that's missing on your frying pan?
Just add more water.
Yeah, but you could do it in a sort of an automatic way. Have a small veil of water upside down, and when the water level goes down, it'll let a couple of bubbles of air in, and that'll let the water come in onto the surface.
Yep. That would work. I'm not too concerned about opening up my system because I'm using the heat, so the vapor replenishes itself very quickly. That's part of the reason why I'm using the heat. It also allows me to open the system up, do my draining, or what I call tunneling with the voltmeter to pull the ionization out of the coating. And then when I put the lid back on, because it's up at high temperature, the vapor chamber, the vapor ratio within the chamber is replenished really, really fast. And it helps reduce the time a little bit, keeps it a little more stable that way. One thing I would be... go ahead.
The pipe where the air goes in and lets the water out could be automatically clipped onto the cover or the side of your container, so you wouldn't have to move it.
Certainly. One thing I was looking at was to actually make a purpose-built chamber that I could heat and hold the temperature up for extended periods of time that wouldn't be dangerous. Something like a really big cooler, a hard shell cooler, and then have a smaller plastic container that fits inside that cooler, put some water in the cooler, float the other plastic container on that water, heat the water up with like an aquarium pump, something that's going to handle the temperature over extended periods of time. And then the inside of the plastic chamber, I could put my nano coating materials in that and seal the whole thing up and just leave it for 2 weeks. I wouldn't be losing water. It would all be sealed. I wouldn't have to worry about evaporation or any of that problems. So that's something I'm going to be looking at for the manufacturing processes coming up. Try to generate a system that's going to work well for the manufacturers too.
Yeah, somebody had used a pressure cooker also. And
yes. Yeah, just make sure it's stainless steel and not aluminum. I have an aluminum pressure cooker, and that would probably be a really bad idea. Also, you don't want your caustic under pressure. If your pressure cooker has an issue, it's going to blow caustic all over your kitchen, and that your wife will not be happy about that.
Aluminum just eat up with the caustic.
It
Oh,
doesn't
yes.
just eat up. It also creates hydrogen, and so you're creating a hydrogen bomb with that situation, basically. And a little spark could ignite it, and it's not a good situation to have it under pressure like that. Because caustic, if it blows out and gets in your eye, it'll poke your eye out real quick. So you don't want to get that in your eye.
My aluminum pressure cooker, it's only about I think 10 or 12 quarts. It's not that big, but it's got about 6 pounds of aluminum in it, and that's going to generate a lot of hydrogen. Rick can attest to just how much you get out of a little tiny bit of aluminum.
Yeah, and once it starts going with the temperature, that's when it starts generating the hydrogen. It takes a lot to get that oxide coating off of the aluminum, actually, and that's why you can put a bundled up piece of aluminum foil into caustic, and it'll sit there for a minute, and then it'll start bubbling, and then it'll rapidly bubble after that, and kind of all fall apart and so on. But it takes a while before that coating of oxide comes off the aluminum. It looks all shiny, aluminum foil all shiny, but it still has a very thin coating of oxide that the hydroxide has to eat into before it can start eating at the aluminum to produce the hydrogen. But it's a great way to produce pure hydrogen gas, actually.
Yeah, I had a different experience. I used an aluminum pan which had a Teflon coating, which was worn off, and I poured some. I forget now because I did this months ago. I think it was cold caustic, and when I realized it was attacking the aluminum, I cleaned it out, and the aluminum ended up with a black coating that looked like the Teflon coating.
Yeah, that would be a really pure aluminum oxide.
Yeah, just as black as the Teflon. Well, a very dark gray.
Yeah. Yeah. Anyway, bottom line is aluminum and caustic do not get along. Please don't use them together unless you have a very specific purpose. Well,
Yeah,
if the south end of Vancouver Island disappears, we'll know what happens.
Goes not on. Okay, it's hard to create the hydrogen
Rick,
there. Go ahead.
yeah, Rick, you could use a syringe, the stainless steel syringe, and put a thin aluminum wire through the hole to your center of your vial. Remember, you, have you managed to generate deuterium? With Mr. Keshe asking us to focus on that. Yeah, but very low percentage. Yeah, but a very well. We don't know. What Mr. Keshe was telling us is we need deuterium to the liftoff.
Sorry, on live stream my audio was off again there. I was trying to switch it back and forth because otherwise it produces some bad sound in the background. What I was just saying that you couldn't hear in live stream once again. I'm gonna have to re-upload or upload a new video for live stream, I guess. Sorry about that. Was that we were talking about? John asked about deuterium and tritium, if I produce that and so on. And I was saying if you had a bubble this big in then or a bubble in the top of the test tube, in the case of when I produce some hydrogen in here, you already have deuterium and tritium. But John says, well, not very much, trace amounts and so on. So I asked, how many atoms would you like? How many do you need? And this is the thing, how many do you need? How many do you want? And then you can kind of think about ways you might be able to get them, for example.
Well, in the moderating pools where you control the radioactivity, it's pure heavy water. It's all deuterium, a very high percentage. I've seen that a couple of times about 50 years ago.
Yeah, you can buy deuterium water. It's not radioactive, and you. Pardon me.
On live stream, we are not able to hear you. I switched from live stream to Zoom.
You can hear me now. You should be able to hear me now. Fine. It's I had the audio shut off accidentally there.
Okay, sorry then.
One of the experiences I've seen is a hell of a big tank of 15 meters high and about 4 or 5 meters diameter, and that was all heavy water with deuterium hydrogen, and the color of that water is fantastic. You never forget that color in your life.
A lighter blue color, like you mean?
Yes, it's
some noise coming through. I think from Wasilio's microphone. I'll mute you there. Thank you. Sorry, go ahead, John.
it's a very distinctive light blue. Yes.
Mm-hmm.
Define it as a radioactive blue.
Right, but deuterium's not radioactive though in water, right?
No, I know, but I mean to define the color.
Right. Yeah, interesting. So,
Can I just ask a question, Rick?
sure, go ahead.
You know when where we saw I believe it was Mark in his kitchen with his different ganses, and he had a run that had coloured water, but there was no gans actually present in it.
Right. Yeah, that was his magnesium sulfate, Epsom salt experiment, where he used, instead of regular sea salt, he used Epsom salt and potassium. What was that? Potassium something from the drugstore, basically. And it was mostly the magnesium sulfate, though, at the regular concentration of salt. And he didn't get any GANs actually come out of it, just the coloration in the liquids, which is interesting.
Yeah.
And what about that? Did you
Well, I was
notice?
just it just made me think where we were just mentioned the color of the liquid, and that just sprung to mind. I just thought maybe he had produced something that we were talking about right now.
Well, copper sulfate is that blue, is it not?
Right, yep. But there wouldn't be, yeah, there's a good chance that's what it would be, actually. The magnesium could get replaced by the copper. Possibly. I mean, if you do that with vinegar, it's a similar thing. It'll put copper and vinegar, especially vinegar and salt, especially pickling vinegar and salt. After a short time, it'll start to turn blue. After a long time, it'll dissolve your copper and turn even more blue.
At the moment, where because I'm just doing a cold caustic at the moment, I've actually got quite a lot of blue coming out on my plates and on some of the wires. Is you got any information on that?
Yeah, it's just the copper breaking down. I noticed with my stainless steel fry pan that it's now copper clad on the inside. The caustic does strip the copper off to some extent.
Well, it's turning blue, though, on the copper plates, right? Is that what you're saying?
Yeah, that's copper oxide, isn't it?
Yeah, it's probably... is it exposed to air?
It's hold on a second.
Copper sulfide is light blue, isn't it?
Okay. I get my torch.
Okay, I've got your video on now. I can see your picture.
I can't turn my torch on my camera down at the moment. Hold on. Can you?
We can see.
Yeah,
you see
it looks
the blue
like.
on the bottom?
Was that a raw copper plate or was that nano coated?
It's nano coating at the moment. I've just got them in some plastic containers, just with the caustic in the bottom. I'm just hanging them there.
Okay.
So I was probably today I'm going to get myself a larger syringe and suck the caustic out, then put it in a kettle and just do a hot caustic once a day, and and just run that for as long as I feel is
Yeah,
necessary.
I would say that your just by looking at the way the nano coating is forming on the plates is that you don't have quite enough temperature there. You don't need a lot of temperature, just warm. Like if you have a hot water tank, set it on top of the hot water heater. You'll get especially with a deep container like that, because you're getting stratification, and
Okay.
your vapor is staying low in the system, and the top of your plates aren't going to nano coat.
Right, that would. I
Are
mean, you can't really. Can you see it there? But
are the
there's a. It's the beginning to nano coat on the bottom, but on the top, there's no real nano coating on the plate itself. But I mean, you can't really see it there. But the antenna I've got on there is jet black.
Yeah,
All the wires have nano coated fantastically, but the plates are taking a little bit longer. I have got I've got a couple of heat mats that I had in a vivarium. I was thinking of
that'll work.
putting them on top of that just to raise the temperature in there a little bit. That would be consistent anyway.
Yeah, that'll work.
the plates aren't touching the liquid, are they?
No,
Okay.
no, they've all got
Um,
There's a gap there. Okay,
yeah.
good.
yeah.
Yep.
Another thing that comes to mind is, how long did you soak your plates?
My plates were in a caustic solution. Um, for it was a 10% caustic solution. For they were actually in there for 48 hours. I was only supposed to leave them in there for 24, but I had to. I wasn't at home to get them
Oh,
back out.
leave them for a week.
In the bath for a week.
Yeah, the if you extend the time of all of the processes, you get a better output.
Right. Okay.
Or in the
Uh,
case of, it looks like your plates are fairly thick plates. Is that correct? They're pretty good.
Yeah. On I've got 10 copper plates nanocoating at the moment. They're 1 mil thick, and I've got 5 zinc plates which are zero point 0.5 half mil thick.
Yeah,
I
those
did
one.
actually attach some wires to them because I wanted those wires to be nano coated. Now they are copper wires. Is that going to, when it comes to producing a zinc oxide, is because I've nano coated copper wires attached to the zinc plate, is that going to cause a contamination of field, or would that be okay?
It
no, it
could
won't make a
it
difference.
could it could change things a bit maybe, but it normally the plates might be connected even with copper wire or something. It's not that big a deal. But back to your other
Okay.
copper plates, they are fairly thick plates. And one thing about thick copper plates is that people find that the plates need to be heated quite well in that initial process. It may be that that I think that the plates should be even preheated a bit before pouring on the boiling water, and to make sure that they get enough of that boiling water, treatment initially, where it's really bubbling up and there's some aluminum foil in there and so on, to increase the heat of the caustic and to generate
Right,
that
and if I
really.
put if I put aluminum foil in there, that's going to obviously it will create hydrogen, but it will also put aluminum in the nano coating itself. Is that
No,
correct?
no. If you added
Well,
aluminum to this system, it would be pretty much a waste of time. You're not going to generate enough heat with the aluminum to make a difference. I think just with if you like propagation mats or the heat mats for your vivarium,
Yeah.
that
well, wait a
do
minute, wait
that.
a minute. Wasn't the original technique by Mr. Keshe? Didn't he use aluminum foil, and he put in some rusty nails and other stuff like that, and as well as the caustic, and that was part of the original treatment, I
Yeah.
thought. And
Because
that's part of the aluminum, is it increases the heat. It definitely increases the heat. It makes it boil and just come up like crazy if you put a bunch of those little tinfoil balls in. And
Oh,
this is why I'm wondering, if we're not following the original directions from Mr. Keshe, this is where things get messed up along the way. And if you're not getting the coating properly, then something got missed, you know, along the way, basically. So this is what I'm wondering about, whether we should go back and make sure we follow the original processes as much as possible. I'm wondering if that is included in the proper, so-called proper process. Like, this should be documented as to what is the proper Keshe Foundation certified by Mr. Keshe treatment for, you know, the very basic of basic copper plate situation. What is the correct environment? I mean, he's talked about the necessity of the immersion, which we've also talked about here, which is very important. That some people are just doing the steam nanocoating or the heat treatment without doing the actual immersion for at least 24 hours, if not a week or something, like John was mentioning. And that's enough to start sort of etching into the plate better, to give it that groundwork basis for the rest of it to grow on naturally and so on.
Yeah.
Yeah, but back to your original question, the blue that's forming on those plates is probably copper oxide.
Okay. I mean, can you see the?
It looks like along the bottom
bottom
edge. Yeah.
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 And on some of the,
No.
so you can't really see it, but some of the wires, they've also got a lot of blue, and I mean they're at the top
Is
of the tank.
did your liquid come out blue as well? Is the caustic blue, or is it just
No,
clear?
the caustic solution they were bathing in is the caustic solution I've got in there.
Right. Sometimes it turns blue when the plates are soaked for a long time. Okay. I was
I
going
mean,
to
it's a
ask
10%
also. I was going to
solution
ask.
as well.
Okay. Well,
Is a
that's.
10%
I think
solution
that's.
of caustic okay, or should I increase that?
I think that's pretty normal, isn't it, John? About 100 grams in a liter.
Yeah, that's pretty close. When I teach the system to grandmas and housewives and stuff, I just tell them, just do it like they're making popcorn, just enough to cover the bottom. And that's the way I do mine. It seems to work really good. I don't really have an issue with it. That's the way Armin did it. We didn't get specific measurements, but that's about, 100 grams per liter. Yeah, you're definitely in the ballparks for sure.
Okay.
Now, the other question that came up for me is, I'm wondering what quality of copper plates they are. That might make a difference as well.
I bought these. I bought these online. Originally I had some copper pipe that I managed to source, but after a plasma reactor group several weeks ago, and we discussed the copper pipe and how that also is an alloy really, and it contains other metals. I held off and waited for the delivery. These are supposed to be 99.98% the copper plates, and also with the zinc plates. I chose to go for pure plates because the GaNs on this initial run is going to be GaNs that I will be using on myself and more importantly my mother. So I chose to go for the pure plates, so I can get a purer GaNs as possible with the least amount of contamination.
And are the plates on the bottom copper, and the ones in the middle copper, and ones on the top are zinc? Is that the way it goes?
That's correct. Yes.
Just wondering. It's almost like you're almost like creating a reactor, or creating 3 sets of fields there in a way too. I was wondering if that might affect the plating on the coating on the plates as well.
Okay, it's interesting you say that because I actually moved them into my bedroom here because I've got an oil-filled radiator in here and the temperature's a little bit warmer. But they were next door in the lab that I'm putting together. when in there, they're on some shelving that I've built, so they've got their own space. They're not stacked
Okay,
up
I
together.
see. Yeah.
So I probably, I mean, I'm probably going to put these back into a bath, a 10% bath for another week, and then put them out into some sort of apparatus to steam them once a day. But when I do that, they'll have their own separate space. They won't be stacked up on each other. I mean, that was
Yeah.
something that I was kind of worried about, whether or not, even though I'm not producing GANs at the moment, I'm still producing a superconductive coating, and whether or not they would actually interact with each other. And that's why I was worried about putting the copper wires on top of the zinc plates, because I was worried when it comes to actually making a zinc oxide, whether or not the copper wires would actually interfere um, with the purity of the zinc GANs that I'm producing.
Well, you are creating a battery basically between the copper and the zinc. In fact, that's one of the first batteries they used in submarines back in over 100 years ago. Was copper plates and um, zinc. No, how'd it go? It was copper and zinc basically in caustic as a battery.
Right.
So we have all the ingredients here: copper, zinc, and caustic,
Yeah.
and that forms a battery connection. But lots of people use copper wires to hold their zinc plates and that sort of thing. So I don't think it's an issue as such. What do you think, John?
Yeah, I think as long as your copper wire is nano coated and it's not touching the brine, that
Yes.
you're collecting your GANs in, I think you're fine. Pretty much everybody, when they're making the zinc or even the CO2 GANs, which you get zinc oxide in anyway, half the time they're using a bare copper wire. Sometimes they're using a nano wire. Sometimes they're using alligator clips, which I really don't recommend. But you
Yeah.
still get the results.
Yeah. Because I was actually on these two here that I've put kind of aerials onto. That one there, the spiral one, and that one over there. I was going to use them, those two plates specifically, for CO2, because I remember hearing, I can't remember his name, but he mentioned how the aerial is acting as a leaf,
Mhm.
in terms of the CO2 production. So I thought, if I put some aerials on there of some sort, and just see, have those two, and then have another one with a green LED, and then just a plain one, and see how the differences in GAN's production and the speed. See how, if there is any difference, with having an aerial on there, and obviously comparing that to the LED, the green LEDs and such.
All right. Yeah. As far as your nano coating goes, I think what's going on there is you've got stratification within your caustic vapor. And I did a test here with a deep container like that, pretty much the same setup that you've got. And they only
Mm.
nano coated up an inch over, like they were in the container for 3 weeks, and they only nano coated an inch up the container.
Right.
So
Good point. Again, the heat makes a big difference, I think, in creating that convection circulation and so on inside the vapors.
yeah,
Yeah.
and it doesn't take much, 85 degrees Fahrenheit, get it up to like 30 Celsius, 35 Celsius should be plenty.
Right. Okay. That's not hot at all. I mean, at the moment, uh, what have I got? I mean, I've got 20 degrees in here at the moment.
Okay.
So, yeah. I mean, raising the temperature, with the heat mats that I've got, I could easily bring that up to 30 degrees.
Yeah.
Yep, that will
And
probably do it, I think.
You know, that
Okay.
that'll create a convection within your containers. It'll keep the concentration of caustic vapor more or less the same from the top to the bottom.
All right, fantastic, awesome. Okay then, that's superb. Thank you all so much.
Yeah, you might
Really
also need
appreciate
to
it.
wrap a towel around it. You know, throw a little insulation at it just to keep it nice and toasty inside too.
Yeah, yeah. What I'll do is um, when I get my mats, because they're just in storage at the moment, I'll have these three together on the mats, and then I can just throw a towel over all of them, and then just leave them.
Yeah.
That sounds like a good way to do it. Yeah.
Awesome. All right. Thank you all very much. I'm gonna hit my video off now.
Okay, thank you, and good luck with your situation, your environment.
And that's exactly it. We're creating environments, and you know, if you have a large area to deal with, it's difficult to maintain a consistent environment within that area. You have to take special measures to keep it all the same throughout.
Yep.
One way of doing it would be putting those three containers into a bigger container and keeping the air inside that big container at a certain temperature.
Yeah.
That's the plan I was planning with the large cooler with the smaller container inside it. Pretty much the same plan.
Doug McDonald says, what about hanging alternate copper and zinc plates in one box for caustic coating?
I think because of the way the caustic attacks the zinc, that you won't be able to use the same conditions for both metals.
Yeah, I think you'd be creating the battery thing again there too, so it would be a good battery, and it might
That battery
interfere.
thing, is that the same principle as what the Baghdad battery was?
Very similar, yes.
Yeah, it's not exactly the same, but similar, I guess. Yeah.
Well, dissimilar metals in either an acidic or an alkaline environment.
Right.
I mean, if you can take a lemon, a strip of copper, and a strip of zinc, and light up a diode with it, you can do the same thing with iron copper and zinc in salt water. It'll do the same thing. It's not as powerful, but you still get a battery. But it's the dissimilar metals in that conductive environment that generates that flow of electrons.
Yep, and almost any two dissimilar metals will work. It's just a matter of efficiency. So.
Yeah. And Lee shows up.
Just in time, Lee. We were just having a brief lull in the conversation here. I was just wondering who am I going to get to produce something here for us.
I've got nothing to show tonight.
Okay, well that's fine. We'll just carry on.
My computer's in the repair shop, and I'm just got my old one configured so I could listen to you.
All right, good. Okay, well, does anyone else have anything they'd like to show for show and tell here, or other questions?
Well, I'd like to talk to Lee about what we were discussing before the show, and that's using the 2-coil car unit as a power source for GaNs production. He's got, your last one I saw was 64. So I'm sure you've got one in there that's nano-coated like crazy, and it's working really good. If you're making GaNs, can I get you to hook the thing up to your GaNs production and see what it does?
Yeah, I can try it. I haven't done that, but yeah, sure. What
Okay,
kind of GaNs do you figure? Just CO2?
Yeah, sure. CO2 is fine. That's the easy one. I was discussing this with Armin earlier today, and he didn't say that don't do it, but he sort of alluded to the fact that, yeah, it's probably going to work really good. And if we can, instead of using electricity to boost our GaNs production, if we can use plasma to boost our GaNs production, then we're stepping, down the road in the right direction rather than, trying to make it work with what we've already got. If you know what I mean?
It's great. I'm kind of shocked that we haven't thought of that before. It seems like
Well,
a natural in a way. Maybe someone
we haven't
has and I haven't recognized it. I can't remember anyone showing that though.
well, we haven't really had a pure plasma source that didn't require some sort of an electrical trigger or outside influence. I mean, we've got the GANs, we've got the nanomaterials. We haven't quite figured out up till now how to put them together to generate this plasma flow. And from what we see with what Jackie Fig is doing in California, what Lee's done with his nano-coated wires, like 5 feet in a couple hours, that's a massive plasma flow. So if we can harness that plasma flow and start using it in some of our experiments, I think we can move this ahead really fast. If it turns out the way I expect it to, we're going to be in for some very interesting surprises.
Okay, how would it get hooked up? What would be a positive, negative, or ingoing, outgoing, and so on? How do you
I
see
would be
that?
thinking, I would be thinking that because the matter state materials or your raw material, not your nano-coated material, because it has such a low plasma or such a small plasma field, we probably want the gravitational attached to that to draw the plasma from the nano-coated materials over to it. Now, again, you can think about it both ways. You can put the magnetical on it, we're forcing the plasma field closer to the nanomaterials. So it may be that you want to set up two systems, one hooked up one way, one hooked up the other, and see what the difference is. Right.
Yeah, with the 3 connections would be best. But yeah, even having some way to compare, that would be definitely a way to go other than memory.
Sure, I'll do that and report back next week.
Yeah.
Excellent.
Please use the ones that nano coated like crazy. Because I know you had a few that didn't seem to work out too well, and we're really not sure why yet. But if we have ones that work really well, then we can be a little more consistent with our results, I think.
Okay, I'll use some of my better performing ones.
Thank you very much.
Doug says, what would happen if we added CO2 GANs water to our car battery water? That's a
Well,
good
I did
question.
an experience with that. The battery of my motorbike. I had a new battery, and I topped it up with GANs water, and I sort of screwed the battery. It doesn't have the power to move the motor to start it.
That's a new battery that you topped it up with CO2
Yeah,
GANs water. Did you
yeah,
actually? You didn't remove any of
but
the liquid from the battery. You just topped it up when it needed it. Was that it?
yes, exactly, yeah. And it sort of lost the power to start the motor. I can use the battery normally, but I have to kick start it.
Okay. What was suggested today when I was talking to Armin, he brought up batteries and the connection to that. And what he was saying was with a rechargeable battery, lead acid battery, lithium ion probably work as well, would be to take nano-coated wire, attach it to the negative post, wrap it around the outside of the battery, and then encase the battery and the nano-coated material in your GANs. Even dry GANs, he said, would do it. And that would assist in holding the charge in the battery. So rather than trying to change the chemistry within the battery, we're adding another power source that we can tap into.
That's a lot of experimenting we have to do. There's so many different alternatives we have to sort of experiment with.
As many reactors as there are stars in the universe. You don't want to even start to try to count stars. So even the scientists
Yep.
haven't figured out that yet.
But this battery idea, Rick, if you remember, there was a lady from, where was she?
The everlasting battery, right?
Central Europe. I can't remember where it was, but she had a 12-volt battery with a little solar cell hooked up to an electric fence. And
That's right.
she put the nanomaterials in and wrapped the thing up in GANs, and we haven't heard back. But at that point, she was saying this battery just doesn't wear down.
Yeah, it seemed to work more effectively. That was her observation on it. As far as the CO2 GANS water directly to the battery water, if it was just the GANS water and it was primarily distilled water, then I don't think it would make too much difference. But if you have the CO2 added to it, or if it has a pH that's more alkalines, if there was any caustic still remaining in the GANs or anything like that, then it would definitely interact with the acidity of the battery. It needs to have its acid, its sulfuric acid, in order to work properly. If you neutralize that acid, it would not function properly as a battery. So that's one aspect of that. I don't know, but we definitely need. I mean, it'd be good to do proper research on that, I suppose.
Sorry. If you overfill a battery, no matter, with distilled water or whatever, if you fill it up too much, it loses its power.
Yeah, it can, unless you evaporate it out again, or somehow you can't just take it back out, and you'll lose some of the acid that way, because the acid mixes with the water. It has to keep its acid level by keeping the water level at a certain level. Too much water dilutes the acid. Too little water increases the acid. So yeah, batteries are finicky that way.
There was something that came up. This is only about a month old, and that is the oxides. I can't remember which is which. The oxides are inherently acidic, and CH3, the non-oxides, are inherently alkaline. Is that, I can't remember if that's the right direction. Okay, so if you're putting an oxide, if you're putting the CO2 water into your sulfuric, if the oxides are inherently basic, then yeah, it's gonna ruin your. What's the chemical formula for sulfuric acid? Okay, yeah, so it is an oxide. Um, hmm. Yeah. So from a chemical standpoint, I don't know if you'd even want to put CH3 in there, because that would increase the hydrogen production rate of your battery dramatically. Hmm. Well, I guess it's something else for us to test. Oh, the little golf
Destroy
cart, or
them
the
in
little
lab tests.
motorcycle batteries. The little motorcycle batteries are the ones you get for your key start lawnmowers. They're only like $15 or $20. They're not too much.
Yeah. I'm just going to leave the sound on and the live stream. I can't remember to turn it on and off here anymore, so let's get too distracted on it. Sorry for the live stream. I had the sound off again for my last little talk there. Ay, ay, ay. All right, well, so here it goes. You work with gasoline. Anyway, what else we got here? Okay.
Hey, Rick, I got a question.
Yes, okay, go ahead.
Yeah, this is Cameron Anderson. Hey, I'd like to get 3 sets of car coils, and I've got a 64 Buick, and it's all steel, no computer stuff, and it's the big engine. I'd like to put 2 of the coils up behind the headlights, 2 behind the tail lights, and 2 of them on the side by the seat post. And see how that works on moving the car.
Okay. The experiments that we've been doing, we haven't used multiple systems. We've only used one, perhaps 2, one at the front, one at the back.
Well, a 64 Buick is pretty heavy.
Yeah, I used to have a 63 Dodge Monaco, so it's pretty much the same thing. What part of the world are you in?
I'm in San Francisco, is he? San Jose, you know.
Oh, okay.
You know
I can get you. I can get you in touch with Jackie. She's in LA and she's doing tons and tons of testing with these things. I'll talk to you after the show and I'll get you in touch with Jackie.
Okay. Or just spell her name.
Jacki.
Okay. And the last name?
Fig. Figg. Figg.
Okay, double G. All right. Yeah.
And I don't know if the phone's in her name or if you're looking it up in the phone book or whatever, but I've got her email and I can shoot you.
Yeah. Do it on Messenger, huh? That way it stays private.
Messenger is not private.
Oh, okay.
I'm sorry, but it's not private.
I don't know what's private.
Do it Facebook or whatever.
Let me see. Okay,
Hey, do you have my phone number?
No, I don't, but I'm going to send you a private chat with my email, and you can get a hold of me from there.
Yeah, if I can figure out how to do that chat. I don't know from nothing on that.
Okay, just click on the chat. There's a little chat button.
Oh, yeah, the chat box on this. Here, okay.
Yeah.
It should be actually flashing right now.
Okay.
And if we connect through that email, then I can distribute privately whatever information needs to go.
Okay, very good. Okay, what else we got here for show and tell time? I was playing around with the little sphere here with the acrylic to see if they would actually. I haven't worked with the acrylic spheres too much because I'm afraid of them for spinning them. But I do have a ping pong ball inside, which I'm quite familiar with. I'm not afraid of ping pong balls. And I've got another acrylic sphere inside of this acrylic sphere. This one, it's almost the same size as this one. You can see it. Should be able to see it there. See it moving inside. So there's actually 3 spheres altogether. And I thought that was kind of cool once I put it together and actually played with it. It kind of moves differently than you think it would sometimes. And I thought, well, what if I spun this? I can't help but thinking spinning things, even though they're acrylic, and I don't trust them because they explode at a moment's notice. Basically, they're not that strong. So what I did was, in fact, I'll show you a little video of it if I can. I think it's this one here. Let's see. Yeah, I think that's the one I did. Yeah, it's just a minute long. Here, I'll put it on. You can see it. Okay, I don't have to share the sound. I just have to share the screen. And get this set up a little better here. So what you see is the sphere that I was just showing you, and it's hung by a string on the ceiling of my living room, as you can see here. And let me just get this. I have to make it a bit smaller to set up here. There we go. And the live stream. Okay, I'll just play the video. So I wound it up on the string, and as you can see, it's rotating. Pretty good speed too, actually. And you can see the one sphere is now rotating in the opposite direction, but the one inside is still, now it's just starting to catch up and go in the opposite direction. The ball's still going in the original direction, and it's starting to go the other way too. And it's kind of an interesting combination, actually. And I think did I do another video of it? I noticed something different. Let me see here. Not sure if I saved that one. No, I didn't. Well, what happened is, what I noticed in a second one, I'm not sure if I got the video on. I think I didn't get the video before the string broke. But what happened was the ball, the ping pong ball in the middle, actually drop down to the center position of the inner sphere rather than sticking at the top. Wish I had the video of that. I thought I did keep it. Just let me check again here. Gee, I guess I didn't. Let me just try to play this again. Maybe it shows it. It actually starts to separate from the well, it's sort of starting to do it there, but the pink ball actually drops down more. I got the speed up in my second test by winding it up more, and the ball dropped down, the pink ball dropped down into the center of the sphere, which is interesting to see that rather than being stuck at the top. So there's a vortex action going on in there. But you can't, oh, there it is. You actually see it here, actually. Yeah, you can see the pink sphere is now centered basically in the rotation. Yeah, there it is. Went by so fast I didn't notice. And now it's popped back up to the top when the rotation slows down. So I thought that was kind of neat that the sphere, which was buoyant, actually centers itself. Anyway, that's it on that one. Not a big deal, but kind of fun as a non-motor type of a non-motorized means of rotation, which is kind of cool. If we could get it to go back up and back down regularly by itself, that would be nice. I was thinking if that could activate it, just the act of it dropping down on a string could activate that core reactor and cause it to start self-rotating, that would be really cool.
Well, you should be able to spin that up, 200 or 300 RPM fairly safely and have it run for extended periods of time.
Yeah, in fact, that does remind me, I do have another video that I'll show. That, of course, I thought of that already and thought I would take it to the next level, which I kind of did. And
Is this a carnage video, Rick?
a which?
A carnage video?
Well, I don't think I showed the carnage in this one, but it's I can put on the audio, I guess, on this one. Let's see. Okay, so in this video I've got my remote control motor set up, and it's a little sort of well, it's a remote control car motor with a battery and a controller and a remote control receiver all built onto a box, and there's a what do you call it, chuck on the end of the motor, and I've got a string in the chuck, and I guess you can guess what's on the end of the string. I'll play the video here. It's just a couple of minutes, I think. Okay, we've got a motor combination here controlled by remote control. Turn that on. Ooh, this on. Okay, now we should be able to control the motor. Haven't tried this before. The motor is connected to a thread here. And the thread goes down to a 3-core reactor. It's got a CH3 based pink core, and there's another clear core around that that's almost the same size as this outer core. So there's actually 3 layers. Okay, so what I'm going to do is spin this up and just see what happens. Try to get that much of the picture in. And if we can get more of a close-up, we'll do that later. So far, so good. I'm going to give it a little bit of throttle. Whoa. Interesting now.
Rick, you have the coolest toys.
Yeah, I just break them all the time is the problem. Note the little vortex on the bottom of the ball. It's got an air bubble underneath of it there. That's about when the... That's kind of fun. Nothing go. Still centered and running good inside. Yeah, it's interesting. The ball's centered now. The vortex changed inside. It doesn't take very long for things to all come to a common slow down speeds, too much resistance in there. Alright, that's it for that one. So, another bizarre little experiment to see what would happen there. It's interesting, but I don't know if it can produce any concrete results as far as being better than anything else. It's interesting that the pendulum effect happens. According to the length of the string will be the period of the pendulum. So it could actually have, you know, if I didn't have that backstop on there, it could have been rotating like a pendulum or like a planet does around a sun. So maybe there is a use for it in rotating and revolving around a central core. I don't think anybody's done that before, to actually rotate and revolve at the same time. So maybe Mark might have done that with his bizarre contraption that he plays with, but it could actually be, you know, it's the way the Earth goes. And if you look at the this as the Earth, and the Earth has its liquid and solid cores inside of its crust, and they're free to move, very similar to the way this would be moving. So if you have this rotating like the Earth is rotating, and at the same time it's revolving around maybe a central core of some sort, it'd be very much like, you know, if this is the central core and this was rotating around it, this would be the sun and this would be the Earth, even though, and this would be rotating itself at the same time. Could be an interesting effect. Okay, that's that. Any questions? Or just questions about my sanity? Okay, I'm assuming that on the live stream the sound is okay now. Let me just check. As no one has confirmed that it is okay now. I think that's the case. It's just for one or 2 minutes there. Alrighty, what else we have lined up here, boys and girls? Actually, you don't have any girls here right now. Anybody else with something they'd like to present? Any more questions, comments, things that need to be discussed? Okay, any interesting stock market quotations? Movies? Want to talk about movies? Shall we just end it for tonight, perhaps?
Hey, Rick, any of you guys get in on the foreign currency? You know about that?
Foreign currency. Currency has been foreign to me lately. Yes, I do know about that.
No, I'm talking about...
You're talking about different kind of foreign.
Iraqi dinar, the Vietnam dong, and the Zimbabwe. That one is... that one is a bond, and it'll pay off big, mighty big. It'll cost you about $54 for 100 trillion Zimbabwe dollars, and it'll be right now, if the RV comes through, it'll be 2 to 1. You'll get paid $2 for every one on the Zim, and you don't have to go through anything but getting it to the bank and when it comes out and cashing it.
Yeah, I've heard a lot. There's a lot of these money making ideas that have been coming out lately, and some of them may pan out, some of them may not. I'm not sure about that. I'm not personally. I don't like the idea of just making money off of money, and I think that's going to be a problem in the near future. I think it'll end up being that money won't be worth anything, and we'll end up not dealing with money anymore. That'll be a good thing, actually. But
That's the intention, is to eventually get past the money.
yeah, well, that's what's probably going to happen. There's a lot of people right now in the stock markets manipulating the money markets, and some of them have that kind of thing that you're doing figured out to a fine art, and they either short the markets or bet on the markets, depending, and are getting other people to put money in groups, in clubs,
Now,
and so on.
stay away from the groups. Most of those are the ones that are putting the shaft to you.
Well, there you go. But do you trust your friends to tell you that they know they've been watching and they think that this one, it's maybe not a group, but an actual legitimate, business and so on. You make 1.5% interest per day on your investment, for example, is one particular one, and other such things. So, and you have no minimum that you have to invest, and you just have to keep it in there for a certain period of time.
Yeah, that's an ex-politician in Arizona that's getting nailed. He's going to be up on a cross.
I don't know. But anyway, there's a lot of these speculation events that are taking place right now, and it could be that basically maybe we're going to end up getting free money in a sense down to the grassroots level to actually enable people to do more and have more in their lives. But I kind of doubt it, because somehow it's it always the guy at the bottom ends up getting it somehow, and the guys in the top get the money, but the guys in the bottom get the shaft. So
oh, you mean the Royal Order of the Purple Shaft with the barbed wire clusters?
Something like that, yeah. It's generally speaking, it seems like that's the way things go. But maybe it's different. Maybe the powers that be. There's a lot of efforts with the very rich now to start giving away their money toward charitable sort of ways. Of course, a lot of the so-called charities are basically rigged once again, and are a way for the very rich don't have to pay taxes on their rest of their money, and so on and so forth. But apparently there are some that have altruistic motives and aren't just trying to shaft others and whatnot. So we'll see if those that
That's the purpose, to start humanitarian projects. Give it to the people that need it.
Right, yeah.
The indigenous, the poor, and the orphans. Bring it in from the bottom. That's what it's for.
So we'll see how far that goes. I've seen some instances of that in the news and so on, but it all depends on how it all plays out, like most poker games.
Isn't it? We've got to gamble for the plasma technology and not the matter technology. The matter, everybody that's speculating on matter is just speculating on money, which has no real value.
Exactly.
We've got to gamble on love.
And then you can start so-called humanitarian projects that are just, if there's an excess of money and everyone's starting supposedly humanitarian projects, then some of them may end up being humanitarian and some may not be so humanitarian, depending, because maybe the initial intention is not completely pure, or things go astray as things progress and so on. It's not so easy to give a bunch of money to the Aboriginals and the orphans and so on and so forth.
Well, it isn't a matter of just giving the money out. You have them work on a project and earn money to get it.
Right.
Building homes, building or growing.
Right.
There's all kinds of stuff. There's replanting the country too. Just put in new trees.
Yeah.
Bankers only make money out of the 10% they have sort of in the vaults. They're just growing out of nothing. We've got, as you say, we've got to grow things out of something concrete, nature or whatever.
Well, if we push more toward the plasma technology, then there's lots of side benefits that occur, and things will be more efficient and more easier to access the different things that might substitute for some of the expensive and ineffective things we have now, such as some of the pharmaceutical drugs and some of there are methods of transportation and so on and so forth. It's an endless list of ineffective and dangerous things that humans do to themselves that need to be curtailed on our planet and in our environment.
I mean, we've got to think of it, nature and universe. They work on a negative entropy. And man always has worked on a positive entropy, which is just killing nature.
Right. We think everything works by explosion and forgot about implosion, for example.
Nature is very much older than the man.
And if we look at nature as being the way the universe works, which is the way the plasma works, then in a way plasma is nature, or nature is plasma. Or plasma is the natural way, you might say. And it seems like the natural way it's going to go. Doug says, Mr. Keshe said in the last Knowledge Seekers workshop, a big thank you from Ghana and Pan Africa to President Trump for stopping the cheap food as aid. I was thinking of that today, actually, and I think that's one of the best things that could happen for Africa, because the so-called cheap food, which is almost primarily wheat,
GMO, yeah.
GMO and very much hybridized, worst possible form of wheat. And what that form of wheat does, that particular protein which they've hybridized, is basically designed to make people hungry. Believe it or not. And if you give people wheat, it'll make them hungry. It eats away at their stomach, essentially. And especially for those who are already hungry, and you give them wheat, it makes them hungrier. It makes them want more of it, and essentially they become addicted in the worst way.
It's like soft drinks. They add salt to a soft drink, so you get thirsty and you want to drink some more.
Yes, exactly. Well, that's the way the wheat molecule works. And a lot of people are now supposedly allergic to wheat. You know, they have reactions from it. Yeah, well, it's because it basically ends up creating stomach ulcer out of the wheat, and it makes you hungrier and hungrier as you eat more of it and more of it, until you start bloating up from all the bacterial buildup from the undigested protein in the wheat. And everybody has at least partial indigestion of the wheat protein. It's just some people have more of indigestion from it than others, and ends up destroying their intestinal tract, like happened to me when I was in my 20s and almost died from it. And once you find out that that's the issue and that that's what the culture has been putting out on people, and still they continue to do this, it's just mind-blowing that humans would hurt other humans that way. But that's the way it is. That's the way our planet is, and it's hopefully that'll change as we become more educated. But we aren't becoming more educated. We're getting dumbed down. That's one of the big issues with when you eat wheat and suck in exhaust fumes. It's a double dose damage that'll destroy your brain, and that's what they hope will happen, so that people just don't care anymore and can't rebel or can't complain about it. It makes them very brain dead but perfect consumers. They just go and get their headache medicine, and which is the most prevalent not disease but complaint by people in North America is headaches. Everybody takes aspirin and Tylenol and all this stuff, which takes out your kidneys and liver and so on, and then you take other things and to compensate for them being taken out, and so on and so forth. It's sort of a tag team wrestling here with those things. Go ahead.
When I watched the movie Idiocracy, I didn't realize it was a documentary.
Idiocracy?
Yes. If you haven't seen it, go see it. It's called Idiocracy. It's a movie. It was intended as a comedy, but it's more prophetic than anything.
When did that come out? Is that a recent one, or is it an old time?
Early mid-'80s, something like that.
All right, I'll make a note of that. Idiocracy.
Idiocracy, yeah.
Is that a government by idiots, or?
I don't want to give it away. It's actually quite hilarious, and it's both hilarious and profoundly sad at the same time.
Yeah, that's the thing about this planet. It's so sad that it's hilarious in many ways. So I think that's kind of maybe the humor of the absolute is irony, and that's what's been said by some, and maybe that's true. I mean, it's ironic if you look at many of the things that humans do. It's total irony, and I'm sure it's a great form of humor for those that are outside the planet looking in and going, look at what these humans are doing now. Like, what a joke. Don't they realize that this is doing that to them? And can't they figure out they're killing off, 5 million of themselves from their tailpipes that are all sticking in their faces? What's taking them so long to figure it out? It's probably a good joke on that level, because it's like looking at an ant pile and you see the ants are all doing something silly because of, well, they don't usually do too many silly things. Ants are very practical. They're not quite like humans that way, but they can do silly things too, and you give them they can destroy their own nests if they take pesticides inside from certain things that they're ripping apart and so on. So even and if we were to look at them and examine them, we'd probably laugh and go, geez, they're so confused and they're doing everything wrong here and so on. But humans are funny, no doubt about it. And we're entering into an even funnier time. For example, I pick up the news and I read this one paragraph where there's 6 different military groups are named. There's the U.S. who's helping these 2 rebel groups in Syria against the ISIS in Syria, but they're working with the Kurds in one area, but they're against the Kurds in another area. And they all having to be careful not to shoot each other's friends at this point, because they've got the consultants, the U.S. consultants are consulting on one side and on the opposite side at the same time. And it's only because they're all coming together in these one or two places in Syria and Iraq, where all the forces are coming together face to face, basically. They say within a grenade's distance away. And you have all these different groups, and they're basically at odds with each other, but some of them are aligned and some of them aren't. And some of them are bombing their friends, and some of them are trying to bomb the other guys to make it look like they aren't. And meanwhile, they've got the residents and non-combatants. They're just scratching their heads trying to get out of the area or trying to live in the area, and so on. And boy, what a mess. And now it's becoming almost humorous, because even the militaries can't figure out who their friends are, basically, and what to destroy. They're just trying to get rid of bullets and bombs as much as possible, but they're not sure if they're going to bomb their friends or not anymore. So maybe that's what it comes down to, is they're going to have to bomb all their friends, and their friends bomb their friends, and finally they're going to go, oh, we don't have any friends left, and or enemies. Maybe that's the solution. I don't know. It's totally bizarre, but I thought it was funny that all of these groups were mentioned in one paragraph, fighting in this one area. And some are enemies and have been for centuries, and others are enemies only for this year because they were friends last year, or friends last year and enemies this year, and so on and so forth. Boy, it's a funny world.
It's the Shiites and the Sunnis that have been battling for 2,000 years.
Yeah, well, it's the Americans that came in and put them in charge of Iraq, and instead of Saddam Hussein, who was actually keeping control of all the groups, because he was the tough guy that had to be tough to keep all those groups under control, and they were progressing in Iraq and actually doing pretty good. He had no plans to take over the world or anything. He just wanted to control that area. And then the U.S. comes in and gets rid of him, and has no control of what happened afterwards, basically. Tried to control it, but ended up, or maybe they deliberately wanted to pit everybody against each other and have ISIS come in, so then now they have another enemy that they can use more bombs and weapons on, because that's what it's all about in the U.S. is dropping bombs. That's how they make their money. They can't stop doing that, otherwise they'd go broke. So
hey, easy, Rick. Remember, Canada is right next door, and you guys have been sending your aircraft right along with them.
That's right. That is exactly right.
It's the white hats against the black hats, the cabal against the people.
Well, yeah, I'm not sure what's it's for and against and so on here. Maybe we should be all just for something instead of against something, I'm thinking. But that's what peace is supposed to be about, is for everybody. But we shall see.
When the United States went into Iraq, the idea also was get rid of the old seeds Iraq was using and put Monsanto in. They got rid of all the historic seeds and just dumped Monsanto there.
Well, also they don't care about growing anything good there. I mean, the first thing they do is go in and spray bullets, spray the uranium-tipped, hardened tipped bullets into the fields, so that you have radiation through all the fields, and you can never grow crops there that are worth anything. So it's totally irradiated, and that can't be removed very easily.
The states have been killing their own people. I mean, the Twin and
and they've just allowed. Speaking of bullets, Trump just passed a law yesterday, I believe it was, Monday or whatever, his Monday law passing day, to allow lead bullets again in all of the national parks for hunting and shooting. So to undo all the rules of the last 20 years and trying to get rid of lead in the environment, and in all, because you shoot something, even if you shoot a tree, the birds and so on eat the lead pellets, and the other animals eat the lead, and it gets carried up the food chain, and somebody actually eats some of the game, and they have lead in the game. Hello. And now it's going to be even more of a problem because they just allowed the use of lead again. They were using, I think, what the heck is it that you use? Starts with B. Beryllium.
Hey, I don't want to get into an argument, Rick, but figure it this way. He's going after the pedophiles, and they're a hell of a lot more in need of elimination than the lead, okay? He doesn't make everything right, but he's been doing some things right. So,
You
just
talking
let it go.
about Mr. Keshe, you mean, or Trump?
No, Trump. He's after the pedophiles. He's got them going, and all the corruptness.
Well, maybe we shall see. We shall see if how close to home that gets for him.
He's got to get past the guys that are already established to get it done. He's fighting an uphill battle.
Yeah, that's true. That's true. Well, we'll see how things go that way. Anyway, I didn't want to get into a lot of political discussion. This is the plasma reactor group. So
Yeah,
probably...
Eric came up and said he had something to share. Maybe we should move off with the political stuff.
Okay, what do you got there, Eric?
Hi, Eric from Denmark.
Oh, okay.
I have made a little tool. I haven't used it yet, but I said I think it was a month ago or so that I would make something.
Okay, can you show us? Do you have a video you can show?
No, but I have a live camera.
Yeah, that's what I meant, sorry.
No music and nothing else but what I want to show.
Great, perfect.
I just have to select the webcam.
Yep.
Yeah.
Okay, let me get you lined up here. Pinned and spotlighted. There we go.
See, what I have made is this thing.
Okay, explain to us what you have there. It's a rotating device.
Yes, down there is a little gimbal motor. You know, the type of motor they use in drones for stabilizing camera.
For camera, yeah, I've got one of those, yeah. They only go about like 300 or 400 RPM or something, don't they?
No. This one runs, you know, it depends on what you feed the motor.
Right, okay. Mm-hmm.
And then there are this 3D printed part. There are 3 screws here that I can screw in or out in order to balance it so it runs smoothly.
Oh, they're just for balancing. They don't hold the sphere on or anything.
No.
Oh, okay, clever, yeah.
And the sphere is like a bulb.
Okay, did you made the little threaded part? Hold it up a little higher there. Yeah, you made that is that a 3D printed part that you put onto the sphere?
Yes.
Okay,
I'm
nice.
sorry for the movements. It's very difficult to.
No, that's perfect. Looks perfect.
Hold it.
Yeah.
So what I have made is these little things.
Right, little cups, nice.
And then
How do you glue them on? What kind of glue do you use? Like an epoxy? Or?
Oh, I just use some 10-second glue. This
Crazy glue or instant glue? Yeah. Okay.
yeah. But maybe I don't know if it's enough stable. But then we can use some other. So I have printed a bunch of these supports for the ball,
Right.
and as I haven't made my own, I have been. I have about 5,000 3D printers, 5,000 hours of 3D printing and experience with that, and I have designed a new printer, but I haven't made it yet, at least not. And the ones you buy, this one has cost, 1,000. What has cost? It has cost 2,700 euros, and they don't know how to think. To be honest, they have done a lot of mistakes doing the printer, so this is not very accurate. So I have gone into my lathe and I have made a conus here, so it runs. Now this is not the precision for the positioning of the ball relative to the rotating axis, but it is just to have a good solid grip on the ball all the way around. I have had it in the lathe, and then I could mount it so, and this doesn't mean anything if it is. I have to get in the middle. How it sits here, it's a sphere. So, but it disturbs the eye if it sits like this.
Yes,
it's
right.
To have it properly aligned.
Yeah.
And this 3D printed part, it has a thread that matches. I draw the thread in the CAD program. And in the other end, I have a surface here that is used to align. So to make accuracy, I have an inner cylinder surface here, and I have a plane here in order to make it run so accurate as I can do on a 3D printer.
And that matches up with your motor, you mean? Is that the way it works?
One moment. Then I have a 4mm aluminum plate, and that the intention of this is two things. 3D printed materials get soft when they reach 50 degrees Celsius. So in order to keep it cool and improve the cooling, I have used this one, 4mm. It has a surface here, and the inner surface and the outer surface is made in one operation. No, that's not true, but I have a precision, what we call it, the things that grips. I have a precision thing, so when I drill the inner, make the inner bore here, these two surfaces run with a quite nice precision. And then I have made this just a model to drill. There's a tab on it that fits the inner hole in the aluminum plate exactly, and then there are the three holes that matches the three holes there, and there are three holes on the inner part that matches the motor. So this is not something you can drill 100 plates with, but you can print one and maybe make 3 or 4 of these if you are careful. Then you mount this on, and then you can use the holes to drill quite precisely so it fits properly.
Nice.
Okay. And and then I have There's another software in it right now that runs with fixed RPM, but what I have made in doing is another user software that can set the RPM with 1 RPM in resolution. I don't quite know yet if this is sufficient. Then I could, small microprocessors, they love integer calculations, but I can fix it to have a higher resolution than 1 RPM per minute if necessary. I don't know if you have any experience with that. And you can see I have some buttons here, and then I can have it running. And the surface on this printed part, there's a conus here, and when you screw in the bulb, if I can call it that, then it sits on this conus, and that gets quite nice accuracy. If you look at the ball now and see the circumference, it runs within a few tenths of a millimeter.
Yeah, it looks pretty good there.
The balancing is not for balancing every individual ball, it's just for the basic balancing, and you cannot avoid a bit of unbalance from the ball, because that is not a precision work either. This is not completely round, for example. It's just fast made for Christmas toys. So
yeah.
So this is what I have made, and I need 2 hours of software work to make the another user interface, so I can have an accelerator function. So you don't, like, if you want to run 400 RPM, you don't want to press the button 400 times, so you can hold it down and then it counts up. And there will be a problem when you press both buttons, then you save the RPM, so that when you turn it on the next time, you don't have to adjust it. You can just push a button and then it runs the preset RPM.
Right.
So that's what I made there.
And did you make the case for this as well, for this, or was this a device with the green and red button on it and the screen?
I have made everything. The design of mechanics is the design of the electronics, and built it. I made the printed circuit boards myself, and I also made.
Wow, you are one handy guy, I must say. Wow, that's great. You'd be welcome on my spaceship anytime.
That's nice to know.
Bring your machine shop. Bring your machine shop with you too.
This is not plasma. This is just the matter of state, and that is worth nothing in the future. But
well, the thing about it is the brain processing and the thought structures that go along with doing everything yourself is what's important, because it's easy to just hire someone else or borrow something from somewhere else and adapt it and that kind of thing, but doing the actual roots and from the grassroots up basis, that means you can take any technology and work from the grassroots and take a bit of this and a bit of that and work with it to produce some sort of final result. And it's the thinking process and the whole attitude about how to approach something and follow through with a solution that's important. You're obviously not stopped by any aspect, whatever it is. If you have to generate your own electricity, you would probably find a way to do that too. You're probably plugged into the grid, but you're not making your own electricity too, are you?
Right now I'm plugged in, but I don't think it will be so long anymore.
Right.
Before you know, I have spent 10 years with free energy experimenting, and
Mm-hmm.
what I know is how to make the electricity. I know how to convert everything and make
Mm-hmm.
that nicely, but I haven't, you know, the problem with the things I have worked with is that they were not, you know, the old-fashioned free energy. There is maybe close to 5,000 inventions, but no one has been as bright as Mr. Keshe, because they put something together and they get some plasma, because that is what they get. And the problem with it is that the frequency content of what we end up with when we convert to electricity is bad for the health for the things I have built. So it affected my health in a negative way. So I decided to put it to a stop, because I don't need the electricity if I'm in the hospital. So
Yeah, right. Exactly.
but now with the macro, it's another story. The problem is I have got a big list of friends that has given me a lot of GANS water and stuff, but I haven't made much myself. I just been through the initial pre-stated stuff, doing something useful for nanocoating. But I decided to make a little machine to nanocoat, so there's a microprocessor controller that can make it in one go after the initial cold treatment. I don't know if I will succeed, and I will automate the draining also. But that's another story. More work.
Well, it sounds like you'll have a few projects to show us in the future, the way things are going here. So, congratulations on this. By the way, I really liking the way that it works, and it takes a lot to, you know, figure out these connections and the way everything hooks together, and print them out in the 3D printer and all that kind of stuff. So very, very good work.
But if someone is interested, I can share the STL files for this. If they have a printer, they can get the STL file from me, and then they can print this themselves. They can make a plate themselves that fits them.
Fits their motor. Mm-hmm. Yeah.
Yeah. So this is, you know, in software we talk about interfaces to make software portable, and so this is the mechanical interface for my part to any motor.
Mm-hmm. Mm-hmm.
I have a few other items I can show if you are interested.
Sure, go for it.
So, but just to see it from the side here, there you can see a slight wobble in the connection between the two sphere halves. But
yeah, but the sphere itself looks very good though. On the top sphere there part looks
it runs
very good.
within a few tenths of a millimeter.
Yeah.
And then there's a little foot here at the bottom of the device, so it can stand nicely on the table.
Oh yeah.
That was this little thing. This is actually a gift for some friends, and makes. Now I have designed everything myself. I have the ability to make more of them.
Mm-hmm. Mm-hmm.
I have an intent to try to make some tests in the future, but right now I have to focus on the basics. I have made something for the car unit also, if I can find it here.
Okay.
That was I have so much stuff piled up here. Yeah, there it is. I have made a winding machine. That's something coupling back now. So no, but There's an extra open microphone somewhere.
Sorry, I think it's okay now. I temporarily disconnected my headphone. Should be okay now.
I don't have any pictures of it, but I have made an electronic winding machine. It's also 3D printed with encoder, so that when the wheel turns, there's an two optic reflectors that counts the revolution, so I can wind them quite easily.
Yeah,
So
many people would like that feature, I'll tell you.
Yeah, but the problem is I have to work some hours to make it, because there's a box that is 3D printed, and then there's a PCB with a microcontroller and some drivers for both. Actually, it's made so that the thing that holds what you have to wind, it is 3D printed with some with these they call it quadrature holes in it, so that the two sensors get this 90 degrees shifted signal between two square signals. This way you can count the number of revolutions, and if you go backwards because you got too far, then you can it counts down, so it keeps an accurate count of the number of windings. And there's also preparations for having a stepper motor that feeds the wire along the coil, so it will be wound more accurately. But I haven't made that because I don't need it for this purpose. If I had to make transformer coils, then I need it, because it quickly gets a mess if you don't wind it on accurately. But this one is 1.5 millimeter. And I have made a 1.6 millimeter for friends, but not for myself yet. And then I have one more here, and that is 0.4 millimeters. Not assembled and fixed yet. It has to be finished, but it is round. And a friend told me if I make this right, I can make 30 megawatt out of it. But I don't need, I don't intend to make big macros. I will make them this size or this size, 1.1 millimeter or 0.4 millimeter.
And how many coils are on that smaller one there? Is it?
It is a macro coil.
The same number of coils? The same?
Yeah.
Okay.
It's just smaller.
Yeah.
But this coil was initially made for the car. I already improved the fuel consumption on my car. So if I drive 80 kilometers per hour with a Volkswagen Passat, then it runs about 18 to 19 kilometers per liter of gasoline, and that is quite good compared to the original consumption. And I expect when I get this one in, a 3D printed stuff where you have something for the coils, and then I will make a 3-arm that keeps it down so it's fixed. I made a similar one for the small coil to make a fixture, and I have now the wires get messed up here. Just to show the principle here, and I have this fixture to keep it, again a 3-arm to keep it down to. This will be part of my room heating. Then I will have a wire to the side to have some copper foil and a small triangle in both sides. I have these water bags in all my house now, and I get a reduction in the heating bill, but it cannot run without addition of heat. I think Mr. Keshe indicated that I need some stronger fields in order to obtain that, and I think such a little macro coil with individual ganses on each coil, you have to use You have to use 7 mixtures of ganses for such a little coil if you want to make it optimum. And I think I will do that because then maybe I can avoid to have more than one coil and then two triangles at the side. So that's also something I'm working on. And this one is for the car macro. It has holes to get it out, but I will saw a little slide in order to not destroy it. I hadn't thought that properly. I can seal it with some hot glue afterwards. And when you need your own balls, you draw them. It takes 10 minutes to draw such a set of balls in the CAD software, and then you print it, and you can put it together, and you can have it here.
Nice setup. What do you think of that, John?
Oh, I love it. I was just going to mention there's a repository called Pinshape, Pinshape, where you can upload your CAD files, and if they're extensive, like lots of work CAD files, you can actually monetize there. And I do have a printer set up here. John Kammerer was very, very generous and set me up with printers here. And I just got my Cartesian printer dialed in. I'm getting some really nice prints off it now. And I would love to get access to your STL files.
Yeah, no problem. You just I don't have time to fix it before tomorrow. I think my day is eaten up. As soon as you get involved with Mr. Keshe, your time is gone.
I know. What?
Sad too, eh?
Yes. What CAD software do you use?
There's 2 CAD softwares. The one is called VeriCAD. That's actually one of the few programs I have paid for. It costs around is it 250 or 300 euros.
Okay, because I can work with DXF files quite readily.
You just need the STL file. If you don't have to redesign it, you use the STL file. That stands for stereo lithography.
Yeah. Oh no, I'm aware how the software works. I was just going to mention that if you have designs that are either not complete or need adjustment, if I could get access to a DXF, I can do some of the work for you, help you out with that.
Yeah, but, it's nice of you, but you know when I have a drawing that's not okay, this VeriCAD software is very, very nice. It has almost anything that is in AutoCAD, but to a fraction of the price.
Right.
And I have owned this software for maybe 8 years, and I pay around $100 a year to get updated with new software, and it works nicely. If you have a part like this, it's actually accessed as a database. You have a tree structure, and you can go to the individual parts. If the recess in here is not as I wanted, the cylinder surface, I can select that cylinder surface on the part and change the size of it. It's very, very nice software. I like it.
Yeah, that sounds like very much like SolidWorks.
Yeah, but I think it's, it's just variation about the theme, what you use.
Yeah, pretty much. I mean, AutoCAD it's really versatile. SolidWorks is really versatile. Even stuff like Blender, you can do that kind of work in Blender if you understand the software, and Blender's free.
I only 2007 I had to install a new computer, and then I did the mistakes in apostrophes to read the end user license agreement, and when I read that, I decided I will never use Microsoft again. So I started using language.
You mean you actually were able to read through the total document? Holy cow! That's a feat in itself.
It was 80 pages. That's the purpose of the long document. But
Yeah.
nobody reads it.
Yeah,
You-
yeah. They don't want you to
but
read the part that says where you sold your soul to them. That one
no,
line that they put in. Yeah.
the
Anyway,
license agreements states that if there is a file on your computer they don't like, they have the right to delete it. I cannot
so
have a computer under such conditions.
yes,
Totally,
totally understand that.
totally.
I've put my email in a private message to you. If you'd like, I can. I've got a PinShape account, and if you want to distribute your STL files, I can put them up on my account for you if you'd like.
Yeah, so I can send it to you if you. This is free to share. I don't need to make any money of it. So
Okay.
you can do with it what you want. We are here to help each other. That's the ethos of one of the points in the ethos of Keshe Foundation, I think.
Yes, definitely. And I
Maybe
would like
one
to
day
talk to you.
Maybe one day I need some advices about some ganses or so. Then maybe you could help me the other way.
Well, I would like to talk to you about the way you wire your coils together. There's a much better process than what you're using.
Yeah, probably. But you know, I'm a newbie in this. I have worked as an electric engineer, making mechanics and electronics and motors, tuning racing engines, and a lot of stuff through my life, and databases and web programming and a lot of programming languages and power electronics. So I've worked all my life. It's just like all my life has been a preparation to be able to do anything myself.
Right. I don't know how well these are going to show up because they're really black. Actually, that looks pretty good.
I have to pin you to see that.
Or Rick, either way. There we go. It's actually focused and everything.
Yeah. That's the thing. You know what I have done here was just a preliminary thing, and what you've done there is what I intend to do on the future calls, because let me see. There's a detail about the upper part, but what the basic idea is that the plasma flows. The inner wire, that's the input, that's where the energy comes from, right?
The inner wire is your gravitational. That's where the energy is drawn to the inner wire, and it's released out of the coil.
Okay, then I switched to 180 degrees. But the idea is that winding this way, you get a good connection between the plasma and the two wires.
Yes.
Basically.
Yes, and they don't have to be really tight. You can have a little bit of space in there, so that if you're assembling after nanocoating, you're not actually chewing your wires up.
Okay, and then I just add some caustic to it afterwards.
Yeah, a little bit of caustic with some sugar, and that fixes the coating right up.
I have a question about precisely that. When I have to make these small ones, and I don't think, to my best understanding, there is no ordinary current in the macro coils when operating. It's only plasma.
That's what's supposed to happen. If you're getting electrical flow through your coils, your nanocoating is not thick enough.
Right. So you have to fix that. And if I understood right what Mr. Keshe and others has said about this, then I should be able to nanocoat and GANs the coils individually.
Yes, you can, but there's an issue when you go to wire everything together. When you manipulate the wire after nanocoating, you're filling it full of microfractures, and it'll flake off, and it's going to cause problems. We don't have a really good way of making the connections after nanocoating yet, but I'm sure somebody's going to crack that.
What I had intended, I don't know if this is completely silly, but the way I have been thinking about this is that when I have nano-coated the individual coils and have gansed them, then I would assemble it completely, and then I would have a current generator putting a weak current through the system. Oh, first I would nano-coat it once more after it has been first nano-coated, gansed individually, assembled, then I would nano-coat it once more in a steam bath. When I've done that, I would add a small current to the coil, a few milliamps or something, and let it sit with that for some time in order to repair cracks. And that will be the final process after full assembly. I don't know if that will work.
I'm not sure about doing a steam coating after the GANS coating. There's actually a test. There's actually a test going on very shortly, if it's not already in progress, in Singapore right now, to test whether or not that's a viable option.
Okay.
And what about the electrical, putting electricity in it? Is that a good idea, or should it be more of a draining process, perhaps?
Well, if you can put a plasma flow through it, that would be significantly better.
Okay.
But the what we're trying to do when we build the nano coating materials is to drain away any ionization, drain away any buildup charge that occurs within the coating itself, rather than adding charge to it.
The way it's explained by Mr. Keshe is that the layers tend to sort of fluff up when the electricity is added to it, and you don't want to have like air and big gaps in between the layers. You want to have it tight to hold the plasma.
Okay, and I misunderstood what Mr. Keshe said. In one teaching, he talked about nanocoating transformers, and the current he spoke about there was actually then plasma current in order to nanocoat a transformer.
Yeah, there's you got to be careful quite often, because English obviously is not his first language, and sometimes the terms don't quite work in regular English. So be careful when you listen to him. Don't take what he says for verbatim, but listen to what he's working towards, because he may not be using the right words.
Well, in the case of the transformer, he was probably talking about the plasma form of nanocoating, which is, probably through the grid lines or something back to the original transformer or something like that, maybe.
Yeah, it could be very, very likely that. I mean, just what was it, 3 weeks ago or 4 weeks ago, he was on the show here discussing exactly what you're talking about, Eric, and that's coating the coils and then assembling the system. And he used the same term coil for the springs and the assembled system, which got really confusing. It took me about a week to figure out what he was talking about.
Yeah. Okay.
I mean, it's what he's telling us is really accurate if we expand some of our definitions a little bit. So, just
okay.
But no, it sounds like you're on the right track, and I love your work. It's gorgeous work.
Yeah, but my idea of, as I said, I'm a newbie in plasma, and there is a Norwegian guy that keeps telling me that, and that we sometimes had a little dispute about it. And I said to him, remember, I have worked with this for 10 years, so I'm not on the ordinary electricity view anymore. I haven't been for a long time. So in that way, I'm prepared to do this. But there's a lot of other stuff and a lot of details and a lot of things you should not.
There's a saying that in this business that we're all newbies in the plasma business, basically. Even those that supposedly have a lot of knowledge or have been around this technology for years, it's still, we, you know, in this group, I learned things about, you know, the example is the copper plates discussion earlier today, the very basic nano coating of copper plates. And I learned things through that conversation, and we all do, or otherwise we wouldn't be talking about it again and again and again. And it's amazing that we would still learn more through what seems to be a, you know, simple thing. What could be simpler than, you know, putting these copper plates in some caustic, you know? But it ends up being quite a complex operation when it's everything's at the nano level and so on. And you're right that previous information and knowledge is important in a way, like you've already investigated different modalities of free energy and all that sort of discussion. And yet, almost everything sort of goes out the window when we start talking about this plasma technology. It's almost a whole different critter in a way. It's hard to get a handle on it, and it's hard to even find the right words to describe some of the things that are going on, and it's hard to even show the results of some of the processes, because we don't always get results like 90% savings on electricity or something easy to measure like that. Even that's hard to measure because of the various things involved.
You cannot measure the plasma
Yeah, it's
accurately.
difficult. So
Maybe
that's why we're all newbies in a way, and at the same time, any one of us could easily, even you know, the most mundane of us, somebody, you know, running a kindergarten or a household, or someone else that's in a totally unrelated field. You know, I've been a mechanic in my life, and I'm used to that kind of thing, and so on. So everybody has their own point of view on things, and the breakthrough could happen from literally from anyone. They just happen to have the right information at the right time, and that enables everyone else to uplift their perspective on things and so on. So it's amazing how it all works, like a big machine.
But in one aspect, I'm not a newbie, because it has been like this all my life. As soon as I learned something, I jumped to the next thing and learned that, and then I jumped to the next thing and the next thing and the next thing. So the plasma is just one more cycle in this.
Mm-hmm. Right.
So, but I can maybe you would listen to my thoughts about the nanocoating process.
Okay.
There's also some gift in here. This is an aquarium, and there I have made a gift for you, a lot of cylinders for those who had a lot of GANS water. Then I made this like a shelf for. There's a side plate here, also 3D printed, that holds five of these syringe things. So you can put in a syringe in here. This is again this not precise printer, so I have to make a tool to clean it, and then I can put this on here.
I think you have to put it a little higher in the picture so we can see better, higher up in, yeah, thank you.
Oh, it's not easy to be two places at the same time.
Yes.
At least with present knowledge, but this is a storage for 50 cylinders, and I have made a lot of that, so that's for 200, because the friend I want to help has about 300 ganses, so and she gave me about 120 of them. So within medical application, I have also had some medical study of the basic autonomy for 2 years, so I do something to help people that is a bit off normal health. But the basic idea about this, I bought this little aquarium, or actually a friend bought it, and it measures 20 times 20 times 30 centimeters. I will make a construction of plexiglass that fits into the aquarium. And in that, I will mount some very solid copper threads that also get coated in the process. So I will basically have two wires going along the aquarium. And I will connect wires to it. And I will, under the aquarium, I will put an aluminum plate with heating elements so I can control the temperature. In order to make the grass survive the boiling water, it will be preheated to close to 100 degrees inside styropor, or whatever you call this white fluffy insulation material. I will make a box around it so it's insulated, and then the parts are suspended by the thick copper wires in the system. And then I will have a microprocessor add some connection between the two wires with, I think, a 20 megaohm, because I have been thinking a lot about this draining process. Because what is it we do with the instrument? The instrument has an operation amplifier. It's a silicon device on a chip. And this operational amplifier, it has errors. It's not a perfect thing. It has a leakage current in the input, and it has a voltage offset. So when we use that, we can not be sure of the polarity of the test pins. It can be either way, but in a small amount, we're talking millivolts and probably microamps. But anyway, it has an error. So I was thinking, when people can use this instrument and get success in making this orientation of the nanocoating, then it probably, in my view, until told otherwise, is that the plasma that flows in the nanocoating is actually the energy sourcing of orientating itself. So if I just make a circuit that is slightly conductive, then I get the orientation. Because
you can do the draining just with a piece of wire. You don't need all of that circuitry.
Yeah, but I need something that is only connected when I will want. I don't. Is it good to have it drained all the time?
Some people have done that and they have results. Most people just drain it every 6 to 12 hours. Yeah, certainly.
Yeah, my idea was that according to the information I got, we need about 50,000 layers. And when I look at the videos where people nanocoating the wires, then you put on some boiling water, and then maybe after half an hour or an hour, the temperature has dropped so much down that the process is very slow afterwards. Maybe that's the purpose of it. I don't know. But I was thinking that if I can control the temperature of the nanocoat container, then I can do my experiences and find out what temperature works the best for the nanocoating. And I can also change the interval I drained it, because I think so that if you build up layer for layer, the most ideal situation would be that every layer is orientated. I think when you do this, you will probably only orientate the upper few atom layers. The other is fixed in position. I don't know if I'm wrong in this, but I think that you have to do it regularly. in order to get the orientation.
How many times did Mr. Keshe recommend originally? I'm trying to think back to the original experiment.
6 hours.
Every 6 hours for how long? For a week? I think it was a couple of days, wasn't it?
Yeah, well, the original process that Armin was talking about is a 3-day process. So you're doing it, 12 times over that process, every 6 hours?
Yeah.
Right.
But
So
that's
yeah.
for each 3,000 layers. Then if we think we end up with 50,000 layers.
Well,
So that's
between
like
30 and 50,000 layers, you're beginning to see the nanocoating.
Okay.
We're looking at a couple of 100,000 layers ultimately.
Yeah. I guess that this process obeys the normal rule that if you raise the temperature 10 degrees, the process doubles in speed.
I don't know exactly if that's accurate, but definitely bringing the heat up improves the process, certainly.
Yeah, so maybe I should run it with maybe 70 degrees for a week and just sit there automatically and send my best thoughts to it regularly also.
Well, we were discussing this a little earlier, and the process that I use a combination of both room temperature and about 90 degrees Celsius. And I cycle it over the day, or first thing in the morning, it's cold. I turn my heat on, bring the heat up, let it heat for several hours, and I'll turn it off, let it cool down, then I'll turn it back on again, heat it back up again. And so far, my coating using that process is turning out very, very nice. Whether it's optimum, I don't know. But compared to the standard nano coating that most people are doing, the coating that I'm getting is significantly superior. We're doing some tests in Singapore right now using heat, using multiple processes over extended periods of time. And so far, the resistance testing that we're doing on the coating is showing us that, yes, we want heat and we want to go for extended periods of time. Do your nano coating over a week at least, if not more.
So just like if I have an oven to make soldering on a PCB board, it has a temperature profile. Then I maybe should make the software so that we get the possibility of programming a profile over time.
Definitely, that would be great. And also, you could try doing lower temperatures to see what changes that makes, just as a comparison. And now the thing about it is, it's not necessarily the faster the process, the better the process either, as Mr. Keshe has said many, many times. And many people have tried to speed up the GANs making process and the nanocoating process and so on, especially with electricity and all that. And I get people that write in with a picture and say, you know, I used 15 volts and 3 amps to make this GANs, and it turned purple and red and green and yellow. What is it? And you know, they ask us what it is, and because they have no idea and we have no idea, there's, you know, a whole spectrum of different compounds and so on that are created when you start using electricity. But it definitely was not the original GANs as intended. And we have the what's called the original GANs, what I call the original ones, which would be the CO2 GANs, the copper oxide GANs, and the CH3 GANs. There's also, you know, CH4 as well involved with that. But those are the three main ones. And we've learned what they look like and how they should be and so on. And then if the process has changed, it'll bring in different types of materials, and some of it may even be the same material and look the same, but it'll be a different isotope of the same, you know, it'll be carbon but a different isotope of carbon because of the higher energies that were used in creating it and so on. It can change things. So this is what gets involved is, do we go with, like Mr. Keshe says, you know, he often says to take a month, let it sit for a month. and some of the initial reactors that were made out of copper and so on, they were treated and repeatedly treated and left for a long period of time for the final layers to build themselves up. It's a self-creating process. Once it's started and you keep a happy environment for it, it'll just go on repairing itself, essentially.
Yes, and when I said I would like to make a temperature profile, it can be a repetitive pattern. It can be a continuous pattern, not changing temperature much. I have all the variations. I can program it just like a simple PLC program, so it's easy to change the profile.
Yeah, with
And
that heat plate you talked about, that aluminum plate, temperature
yes,
controlled
with the
plate,
heating
that's
on.
great. Yeah.
And the
Well,
idea of doing this is repeatability,
yes,
because
and that's it. It just occurred to me. This is the exact question and situation that we were discussing earlier, with the plastic buckets and or plastic containers and the variance in the levels of the vapor inside and so on, and a lot of that's due to the heat condition of the unit, and it's because it's not a controlled environment. And you're talking about having a controlled environment and actually nailing down the parameters, and that's really what we need to do. And then it would be easier for us to say to who was it that had that earlier, the containers, John, I think it was. Anyways, we'd be able to say, okay, well, you need your temperature controlled better. We found out through these experiments of Eric that the temperature makes a huge difference. It has to be between X degrees and Y degrees, and not below Z degrees, or else you'll end up taking forever to get your GANs going and so on. So yeah, if you can do some experiments that way, and you seem pretty thorough in your testing, and your intuition seems good too, so you should be able to come up with some results, because this is actually what Mr. Keshe is looking for more and more, is more concrete results, like maybe a table showing this experiment and this result, and this parameter changed and this result, and so on, so we have something to compare to.
yeah, and that's what I have been lazy all my life, so I don't like to hang in a string in order to get something very accurate. I try to do some tools to get a better job done, and this is the case here also. So I think when we come to I come to a point here where I have full control over the environment, and I can compare the results I get, then I will be able to home in on a better nanocoating, I think.
Yes,
And
but we do have to be careful as technicians, let's say. It's because I'm a similar way to you, Eric. In fact, my true name is Eric and not Rick, E-R-I-C, not E-R-I-K. But in any case, I'm a tinkerer, and I played with everything from electronics to different machines or whatever. It's just I'm a tinkerer. And because we're tinkerers and we like to play with the parameters, then we always like to get our hands on and control and keep trying to narrow that down and so on. But at the same time, sometimes we have to do well, like Mr. Keshe says, and just leave it alone. Like it's our temptation maybe to open the box and peek in and see how the nanocoating's doing. And then when we do that, we let out all the vapors that are busy working away at the nanocoating, and then we put the cover back on, and it takes another day or two for those vapors even to get close to where they were before. Maybe they don't, and so on. So keep that in mind, that because we have minds that are busy wanting to check everything all the time and alter and tweak and so on, sometimes it's better to just let the process take care of itself. Because thing about this, to me, the whole miraculous thing about this copper oxide in itself is that it is a self-creating process. It's a self-healing process. So that they use copper oxide, the black copper oxide, inside of nuclear reactors for the walls, because when the radiation knocks off some of the copper oxide, it repairs itself. And they don't have to, go in and start replacing and repairing panels, because it's a self-repairing substance that, if it gets scratched, then the scratch basically self-repairs in the right environment, where you have at least some remnants of, if it's too acidic of an environment and it's scratched, it may tend to wear off the coating more there. But if it's the right alkaline type environment, maybe some wood ash sprinkled around or something like that, then bingo, it starts self-repairing.
Yeah.
Anyway, I see
And,
Doug's waving there. Hi, Doug. Go ahead, Eric.
Yeah, but it doesn't change the basic idea, because I can add a fan to it, so I shift the atmosphere in the box if necessary. I'm so much technician that I think that there must be some kind of optimal process to do this right.
Yes, but see, there you are. You're wanting to start adding things to the basic thing. And this is what everyone's done, and it's a wonderful thing. And Mr. Keshe never says no to people who want to, branch out and investigate and try new stuff and so on. But just watch out for the trap, because every time we try something new means that's a new creation. And it's not suddenly that original CO2 GANs is no longer exactly the same GANs as envisioned by Mr. Keshe for a particular use. It becomes another GANs that we've created,
Yes.
and added something special to it that we think is an improvement, which it may or may not be, which,
I listen to you because I do it for one specific reason. I have had the experience with health issues because of these inventions.
right.
And the right thing about Mr. Keshe is that he used materials that is a natural part of the body. So the
Exactly.
that comes out of this when we work with it is frequencies that are good for your health.
That's right. And
I will never, I have done, but I will not again go away from the specific way Mr. Keshe says to make the ganses. That I will not experience, experience away from the guidelines he has given, because
right.
I know the health issues. I made some CO2 GANs with a carbon stick, and I don't know if it's worth anything. I don't dare to use it, because if it has a long-term negative influence on my health, then it's very stupid to use it. But
Right, that's a really good example. Like when you mention that, I don't know. I wouldn't know what to recommend about that, whether it's better or worse or anything. It'd be good to, I could say you could experiment on yourself with it and see, but that's not very fair. What I would always suggest is go back to what Mr. Keshe recommends and has done from the beginning, unless he recommends otherwise, that we decided that this stuff is not good to be using, so don't use it or whatever. But that's seldom. It seems like his basic initial ways of doing things are pretty they're backed up by some safeness involved. And in the case of making ganses and so on, for example, lots of people have made all kinds of strange ganses, you know, like lead gans is a classic example, and this kind of thing, and they all need to be experimented with. But on the other hand, we start to get away, as soon as we get away from the CO2 and the copper and the zinc, then we start to get away from the elements of the body, like you were just suggesting. And you know, the copper and the zinc and basic, you know, carbon and oxygen and throw in some hydrogen and maybe some nitrogen somewhere there. And you've got the things of our body, the amino acids of our body. And the amino acids of our body don't include some of the, you know, lead is not one of the essential minerals of the body, so far as I know, and
Certainly not.
so on. Some
Yeah,
some
it is
radioactive
because
things
they
are.
poison us, but yeah, unfortunately, lead is part of many people because of the poisoning effect. But
Yeah, yeah. I'll have lead with me for all my life.
and this is the core of when we do nanocoating. I think we can safely do a lot of experiments to make the best nanocoating. But when it comes to the ganses, we have to remember we are human beings. We work within a frequency range, and if we create materials working outside that, there's no guarantee for good health afterwards. And I have
Right.
experienced this myself, and although I liked it very much to work with it, I had to stop. And I was thinking something new will pop up at some time, because the time is ready for that. And then I found out that because of my dedication to other projects, I was 4 years late on starting with Mr. Keshe, but
Well, there's a reason for everything, and I'm really glad that you are connected and are working in this realm. I think you'll make rapid progress, and
I
well,
hope.
I know you will because you've already shown us that. So this is great, and I hope you just. I don't want to discourage you at all in terms of the ganses or anything like that to experiment in any realm you wish, but I just want to say it more for other people because I'm aware that you know what's going on with the ganses and know what's, you know, correct and not correct, perhaps better than most people. But a lot of people they just, you know, don't have the background and they just start experimenting, and sometimes it's better to have some guidelines there, I guess, and not go too crazy with things. But really looking forward to your interpretation of what this technology can do, because you've got such a cross-pollination of abilities, not just abilities, but the knowledge of these different realms, and you can transfer the realms of the plasma, like for example in maybe creating detectors for detecting plasma. You know, there's a big calling for that. And
Yeah,
how?
but you know, I showed this very simple Abramenko plug. It detects it. I use that all through
The very simple what again?
the Abramenko plug.
Is that the
I showed it.
rotating?
I showed it. No, I showed it around Christmas. I think I have a.
Shandor sharing his screen. Is this what it is here?
Yeah, it is. Oh, is Santa with us?
Apparently, he jumped on it here.
Yeah. I know this. Mr. Keshe does not like this, but I have been told that it's not good that I tell this, but you know, I can. So it's switching cameras. You can see I have it here also.
Okay, let me go back to Shandor. Let me go back to him here for a sec. Thank you. And sorry.
I can go to my webcam again because it's much better if I want to share. I bought a little inexpensive webcam. It cost what is it? in dollars. It was 400 Danish kroner. It's about $50 or so, and that's full high. It's full HD, and it's works very nicely, and it has a good focus function also. This is the picture I made. If you have a short moment, I can get a physical thing.
Sure, let's have a look at it. Thanks, Shander. I didn't mean to cut you off there, but he was offering to show his picture, so thought I'd go with that.
Sorry, I just rushed from the kitchen because I heard of a Avraменko plug.
Oh, okay. When did you run into it, Shandor?
Sorry?
When did you run into this idea? I haven't heard of this.
Avraменko plug, several years before. It was an invention for energy, for AC transmission in single wire. So instead of two wires, you have only one wire. And these two diodes are making the split, and where there is the LED in Eric's picture, where usually is a capacitor as a filter after the already the voltage, and then later you connect the load. It was academician Strepkov from Russia, from VS section, which means it's an institute for electrifying the agriculture to avoid the crop fields to be contaminated with oil. I think you agree with the purpose. And Mr. Avraменko, oh, it's beautiful. Mr. So use it as a detector. Avraменko came into his office and he has shown him something. He used this special plug and he connected with one single wire a fan to the mains, to the wall outlet, and it was running. Since when he was hired.
Okay, and so it doesn't work on any antenna. There's no return circuit back or anything, right? It just works strictly on the wire. Okay, go ahead.
Let me explain. This wire here is this one.
Okay.
You see the two small diodes?
Yeah.
And you see the light emitting diode.
Mm-hmm.
And you see on my drawing, I have this dotted line, and actually you see here, if I can get it in. So here I have the wire. I've drilled 4 holes in it. 2 holes for the. This is an ordinary pneumatic tubing for factory automation. And I took a piece of that and I drilled 4 holes in it, 2 for the LED emitting diodes and 2 for the wire. This wire is connected to one side of the light emitting diodes. Then it goes up through here, threaded through these 2 holes, and then it extends to about my thumb here in the other end. And the idea of making it this way is, if I hold it here, I have almost no coupling to the light emitting diode. Then it's insensitive. So if you have very, very strong fields, you avoid burning the LED. So if you have to measure something, you can always start holding it like this, and if you get weak light, then you can move your hand longer. And if it's very weak, you can go and touch the wire next to the light emitting diode. Then you have a very sensitive thing. Very simple to build and very cheap.
It's a great idea. By the way, if you want to avoid the burning the LED from a couple of transistors and a resistor, you can build up, or just a couple of transistors, you can build up a constant current generator, which limits the current.
But this
You
was
set it up to 20 milliamps or how much the LED needs, and it will never go over. That it is a part of the integrated circuitry, where instead of resistors, they produce easier transistors, so they use such a constant current generators. You can Google for it, constant current generator circuit.
Yeah,
Could
but
you also
Okay.
could you also
Now,
use a Zedier shunt across that LED so when it voltage reaches a certain level, it just shunts right through?
seems like it might get too
For
complicated.
current source.
Thing about it is that you're still using your body as a return antenna system back to the other part of the circuit, right?
yes, and you couple to everything.
Mm-hmm.
You cannot have a device without coupling to it. That's
Well,
the way it is.
that's true even of those crude electrical field detectors that everybody's using for measuring the magravs and so on. It's a lot of it depends on your body, where you hold the device and the charge in your own body and where you are in the room and so on. Okay, so what do you got there now?
If you are worried to burn out, then you can make this little circuit.
It just it's like a current limiter circuit, basically. It looks like.
This is a current limiter. But when you do such a thing, you don't you miss the impression of the strength. I have never burned a diode in this circuit, never. So
Yeah, and you can almost put a voltage scale on the side of the tube because like you say, you can tell the voltage or how much potential's there by where you grab the tube, how bright the light is, right? You've gotten used to where that is.
when you use it, you have two ways to measure. One thing is where you hold it, and the other thing is the distance to the thing you measure. When I made, I made something just like the old Tesla thing. I made a ball and a rod up to it, and I had made a little cube of PCB boards with spiral coils on it and a transistor and a light emitting diode indicating when this was running. And when I came with this little indicator here, I could get up to maybe 30 centimeters of excited space around the ball. So if I came in within this distance, it light up without touching anything. And on this actually, in this circuit, there was only a single transistor, and here I had a lead emitting diode to limit the negative voltage for the base so it didn't burn off. When I had this running and have several of them that transmitted energy wirelessly, then the current in this light emitting diode in the limiting part here was so strong that it burned out a 20 milliamp. Even though this was not connected to anything, it was self-oscillating due to the influence from a single center. I built up a circuit that when I had a single thing connected to a battery, it had a consumption of 1.4 watts. When I added more receivers, the consumption was reduced. And at last, I had about 30 light emitting diodes running and 2 meters of fluorescent tubes. And the consumption was reduced to 0.4 watts. But the protection from the light emitting diodes in this circuit, they were running so high in current that it burned 20 milliamp. And I had to buy 100 milliamp light emitting diodes in order to not destroy it. And that's quite impressive that it gets, because this is actually a transformer. Here you have low voltage and high current, and here you have high voltage and no current. That's some of the things I've used. It's quite impressive. The more you load it, the lower consumption it has. This way you can do something also. The problem is that the frequencies emitted is not harmful to your health. So maybe you can design it another way and tune into some other frequencies and get some positive results, but I gave up on it. I didn't like the way it was. So, but it was good. It was, I generated some plasma with it, and I think at least it was some plasma because I excite the space around it, and this is not a radio antenna. It has been proven by a PhD that taught some of this. That was an interesting part. I learned a lot of doing this and other circuits like this and the other converter I showed you around Christmas. I actually built a circuit with a lot of small printed circuit boards, so it's modular, and I can quite quickly build a converter. I have a little control box, and I can control the frequency of it. I can control the load on the circuit with it, and do conversion in a test setup. And then when I have something that I'm satisfied with, I can do a specific printed circuit board for it. And that's what I intend to do when I get this done. But right now I don't have it. I think the best thing is to use such a small thing and have it running nicely, and then put one in each device you have to use. If you have an electric radiator as a supplement to the room heating, which I haven't got fully self-running yet, but I think I'm saving about 30 to 60% of my heating bill right now. And that's interesting because I use a lot of money for heating the house. So there's a lot of things I have going on, but I think I have consumed more than my share of time today. But I'm very thankful if I can lean a bit to you guys, because I can do some of the matter of state things, and I'm sharing what I have. I have no idea of making money out of it, so I will be glad to help you with the things I've made. But if you have to do the electronics, you have the problem that it takes some time to make a PCB. For example, the PCB that's in the winding machine, it takes most of a day to assemble. I think there's 250 components to it. I use surface mount components, so I have small PCBs with a lot of stuff on it.
I see. Thank you for the overview of what you do, Eric. Very interesting, and I think everybody got something out of all the stuff you were saying. So it's very, very good, and I hope to see more of your input in the future. Feel free to expound anytime you like, and we'll try to help you through any questions you have or any other sharing of insights and so on. Shandor has something he's gone on here with. So what do you have there, Shandor? The idea would be maybe to shield the box, and that's the part that we're talking about.
Sorry, I had muted my microphone.
Yeah, we were just going by sign language there, so
sorry. So you can make an expansion of it to have a series of LEDs to have more lighting if it's a higher voltage. You put here the Raman plug, then you connect. You add a capacitor or a filter, and you add a series of diodes similar to which you used here the first. You will have a voltage drop on each. And you can add as long as you want. Just I draw 4 pieces only, and from now on you put such a resistors. I think some 110 kilo ohms it will be suitable, but you can calculate the circuit if you want. And then you add at every this point sorry, I'm still thinking in terms of discrete transistors. So you can add such a transistor, an NPN transistor to each. So you give the voltage to control its base, whether to open it or not, like this. And let me draw the fourth, not very beautiful drawing, but maybe you can understand it from there. And you put these all emitters here to the ground. So this will be your so-called ground, G and D. And you add here your LEDs. 1, 2, 3, 4, etc. Every LED must have a limiting resistor, let's say 1 kilo ohm, for instance. So let's say here you put 10 kilo ohm resistors, and here you put sorry, change the style of the symbol. So here I put resistors of 1 kilo ohm in the collector circuit. So this is limiting the current of your LEDs, but you can calculate it very easily.
Yeah, but you know, Sandra, I would just make one single current limiter. And
I understand, but this circuit would need a small battery. Let's say a 9 volts battery here.
Okay, the idea is to quantify it.
And here you will have the LEDs lighting 1, 2, 3, 4, or how many you want. You have a higher voltage input, you have more LEDs. So your instrument, it will be like a VU meter. So you make your instrument like this with 9 volts battery included inside, and you will have here a line of a row of LEDs.
Yeah.
And you will have lighting 1 LED or 2 or 3, and depending on the voltage. So this could be for those passionate in electronics and who are not afraid to make a small circuit. You don't even need a PCB because there are a few components. You can just stick them together. You can solder them together. You can build such a small toy.
Yes,
it would be a deluxe version.
Yeah, but you know, as I said, I'm lazy, so I just
okay, I understand you. Let's continue.
I used to use the intensity of the LED to judge the amount. You can easily see if it's barely lighting or it's very intensive, so it really burns your eye. That's an indicator that is enough for me. But of course, if you want to quantify it, you can do it more accurately this way you sketch, and no doubt about it.
Yeah, rather the thing instead of the LED, you can put a voltmeter, for instance. But it should be an AC. No, it's a. Anyway, you can put a voltmeter there and exit. That's the other.
Yeah.
Well, okay, what are we measuring with all this, though, is the thing?
The way I understand this is that, you know, I haven't quite adjusted to the plasma in the way, because in the old, now I speak in my old terminology, I call this cold electricity because I think there's a duality. You have the hot electricity, there the current is the things to obtain, and you have a closed circuit. When you have the cold electricity, you have an open circuit and there's no current, there's only voltage. And according to Walter Russell, you can polarize the ether, as he calls it, and I think that's what Mr. Keshe calls the plasma in some way, more or less inclusive. And the ether has an impedance of about 200 and 270, 300 ohms. And there's some papers by a guy, now I don't remember the name. I had a crash down on my computer recently, so I don't have all the documents there. But there was a guy that has made 3 papers on the ether and the effects of nonlinearity. You know, when you work with something, you work with you can have a lot of inventions that work on parametric conversion. And when you do that, you gain energy in that kind of circuits, and you have a lot of old-fashioned inventions within free energy that works on the principle of parametric conversion. And the polarization of the ether, that is the thing that influences my little device here, to my understanding.
I think this instrument is measuring alternating electric field, so an AC electric field.
Yes, I agree.
So it's not measuring plasma, it's measuring an electric field. For some electric engineers, it seems very odd that you transfer the energy through a single wire, and not through 2 wires. And this was what shocked many people when it's about Avramenko plug. But those who have experience in radio electronics, for them it's very normal. You have an area, you have a receptor at the kilometers, and you receive energy. And this is how radio works.
Yeah, but
you don't need 2
you know,
wires.
I know this. I know this is not directly related to Mr. Keshe, but there was a guy named Dr. Stifler, and he was a PhD in radio circuits and very skilled guy. I must say he was one of the brightest guy within ordinary electronics I have seen, analog electronics, and he showed set up with some aluminium blocks. And if you measure the capacity between those blocks, it was less than 5 picofarads. And even if you had the high frequencies, the energy transfer from that is close to nothing. But he could make circuits that when he actually detuned his circuits, because if he didn't do that, they put out so much energy that they destroyed the circuits immediately, burnt out the LEDs and so. And one time I achieved a good tuning, and it turned off 2 computers, and I had to remove power from them in order to get them working again. And just a little simple circuit with 1 transistor, consuming about 1 watt. But I got some very intense light. I made like this circuit here just with 64 diodes instead, big diodes, and I got very intense light.
Yeah, very good. About electronics, those are understanding well electronics who understanding well the basics. To make a parallel, you can buy a fancy house, but if you know what is a brick, you can build any kind of shape of house, if you understand how to put the bricks together.
Yeah.
Yeah, there's
electronics, you understand the simple circuit, how it, the simple component, how it works, and basic laws, and it's like a Lego toy.
There's an older electronics manual you can get on the diode, and it's about, I think, 60 different uses for a diode in different circuits, in different ways it can be used as detectors and a whole variety of uses besides just in a crystal radio. It's one of the main uses, for example. So yeah, it's amazing how simple things, and back in the old days that was important. Nowadays you can't even hardly buy a single resistor or a single capacitor or a single diode even, because everything's integrated circuits and whole chips that include millions of transistors and resistors and capacitors all in the same tiny little chip. And
Yes.
I walk into my favorite electronics store, and their section of individual resistors and components is slowly getting smaller and smaller and smaller, to the point now where they have to actually order in special, just regular old resistors and capacitors and so on. And people are getting frustrated that are experimenters that like to use that kind of thing. But that's the way it's going. The modern electronics people don't mess around with resistors and capacitors so much.
Yes, but this is partly technology and partly dumbing down. Now I just removed the little circuit that I have made. I can hold here. I can show the inner parts of this rotating device I showed you. Maybe I should go up here so you can see that we are talking about some very small things. I'll see if I can get it right.
They are getting smaller and smaller.
A little bit
I
lower.
remember in the 90s, I did a test job of electronic technician, and it was to troubleshoot such a circuit board.
Holy
And
cow.
having enough experience of what can be broken on it, I found in 2 minutes it was a cracked such a SMT surface mount resistor.
Yeah.
And
nice.
I asked, do you have a spare one? Yes, of course. It was 3 millimeters long and maybe 1.5 millimeter width. And okay, give me please a soldering iron. And the engineer was amazed. He had never have seen somebody replacing by hand such a tiny component.
Yeah.
Yeah, I tried to do something like that on Guy's little music player thing, and I totally fried it.
The trick
My
is
soldering iron was way too big.
The trick is that you have to consider its contraction, the thermal contraction. So first you fix one end, you wait till cools down, then you fix quickly the other end.
Mm-hmm. And quickly is the key word too.
Yes, not eating too much.
And the right size soldering iron is another hint.
Yeah, the soldering iron, it's important you have a good quality if you want to do this.
And
the smallest thing I have, you saw the thing that was here was, I think, 0.5 millimeter in the pin pitch. And the finest circuit I have been able to make both PCB and soldering is 0.4 millimeters, but then it gets a bit hard to do it, and I need some
in factory they're using robots to place those tiny bits, and they use a special paste which contains solder, and they put it all into a microwave oven.
Yeah.
Just to melt them together. So here is a picture from the internet which shows the evolution of the sizes of the components.
Yeah. The smallest components I have is 0.8 millimeter. On the lot, it's the dimension.
Yeah, amazing. Oh, you see, have good eyes or good microscope.
Yeah, luckily I have a good sight, and it got improved a bit by Mr. Keshe. It's impressive what he has given us. My health friend, the one that runs a clinic, he has got his eyes improved so he can read the text on the television if he wants to watch TV. So that's a good thing. And my mom also had an illness in the eye, and she's getting checked. Her vision is getting checked regularly, and the doctors could not understand that her eyesight was improving and not deteriorating as they expected. So a big thank you to Mr. Keshe in everything. You know, we can spend all the time thanking him, and actually we should do that, but it gets a bit boring. We know to me, it's self-evident that everything I do, I think of Mr. Keshe and thank him a lot, because what he has given and what he has endured personally to get us to this point is very impressive. Nobody in history has done this before. Nobody.
Well, that's right. That's something that's definitely to be considered.
Yeah, but now I have eaten all your time.
Well, one way that people can give back is by keeping track of the things you're doing and trying to quantize things more and more in terms of let's nail down the parameters so that we can, when we write a manual for how to make GANs or how to do whatever nanomaterial, then we know the exact parameters in a more scientific way so that all the variables get nailed down. So anyone should be able to replicate it anywhere else in the nearby universe, if not the universe, at least under our gravity condition, because that's not something we've done outside of in space yet, I don't think. But we can nail down the parameters and start to quantify things better, and in terms of the health and healing things as well. And there's testimonials that people can send in at the Keshe Foundation website. You can send in your testimonial, and I'll make sure it gets put in the testimonials section, or somebody will. And that helps to give feedback to Mr. Keshe that things are progressing and people are taking the knowledge and running with it, and we want to be able to document the new things we're doing and the successes, especially in the health sector. That's a big one, but also, of course, energy. Let's, if we have ways of creating the pulse maybe for the maggrav to make it a self-standing maggrav, maybe that's something that we could work on. Or let's get some lift happening. That's been the prime directive for many years, to see lift. That would be great to actually accomplish that. Sorry, I was trying to get to you there, Plasma Head. I saw you had your hand up. So go ahead there. What do you have?
I wanted to ask y'all if y'all have has anyone considered anything about those donut rocks that were in Africa a while back? Well, a long time ago, and
donut rocks.
Yeah, I've been working. I've been working with the GANs like really intensely. This is just so phenomenal. But anyways, I got these ping pong balls, and I've been layering them, in a certain way, and then I'm trying to think of the easiest, softest, cleanest possible way that we can eliminate a lot of issues, without everything being so 360 backwards. It's kind of disturbing. But anyways,
no, I don't have a clue what you're talking about. Could you elucidate me? And what do you mean? What are you talking about?
Well, I'm talking.
What's 360 backwards? What's all backwards?
As far as technology, because we're driving cars, it's things could be so much easier,
Okay, yeah,
but it's just the way technology has gone to today, or since Mr. Keshe brought this out to us, bless his soul. But anyways,
it's going backwards. You mean now the technology of today is going backwards?
Yes. Okay. Well, anyways, working with the GANs, I've realized how the fields expand, and ways to break down the GANs a little bit, and it kind of helps it intensify. But I was thinking, if I filled the ping pong balls in a certain, order, and and then hollowed out the center in a specific way, that wouldn't it resonate like just pure beauty, man?
Do it and show us and tell us about it. I
Okay,
don't
I will.
understand
I,
what you're doing. We'd have to see some pictures or drawings or something of exactly you want to do. And even then, we can't tell exactly what's going to happen on your end. You know that.
yeah.
What ganses are you using? What techniques? You know, there's millions and millions of ways to do things, and each little difference will make a difference. You
Yes,
can,
yeah.
you know how to use your heart to find your way through that, and you might. I'm sure we can. Why don't
Man,
you
this
come up with
knowledge,
something and start something, and then we can have something to comment on and guide you with, and so on. And maybe you can guide us through it. That'd be
cool. Thank you.
pretty cool.
Thank you. Thank you.
I know you're pretty innovative there, Plasma Head, so go for it. Go for it. What do you got drawn there, Eric? Is this you have the maggrav and what's the thing on the right? The
That's a converter.
converter. Let's see, converter. Mm-hmm.
Yeah, maybe I should write it here.
Is that like the heartbeat of the maggrav, perhaps?
No, this is the heartbeat.
Okay, all right.
This
It's
is
like it's an LC circuit, basically. A
yeah,
resonating LC circuit there.
yeah.
Uh,
And then
that's inductor capacitor for those that don't know the code. Go ahead, sorry.
to my current understanding, you know, I haven't built anything yet, but I have some experience on using those circuits. And to my best knowledge is that such a circuit like this, if you have an inflow of, now I say cold electricity, plasma, whatever you like to call it, it will sustain, especially if we nanocoat the coils. Then you only have the losses in the capacitor. You can reduce the losses in this LC circuit a lot if you nanocoat the coil. I think that maybe not.
What about using a plasma capacitor instead of the capacitor there as well?
This is just symbols. I haven't, as I said, I haven't built anything yet.
Well, this is an interesting idea, and that I'm running across the same idea for the coils and electronics in a simple crystal radio circuit, and to nanocoat the coils. And so I haven't actually done that yet. I haven't used a nanocoated. You know, what about take the whole crystal radio circuit and nanocoat, dunk the whole thing in caustic, and see what it does for it. You know, it's a totally different ballgame. What if you took a Tesla coil and instead of having the what do you call it, a resin coated wire that they use for the winding on the main coil, what if you used fine nano-coated wire and nano-coated the whole thing, you know, afterward, and that should form insulating layers between each of the wires in the same way, so it still should act as a regular Tesla coil, but also with the plasma coating involved as well. So I think there's lots of room for experimenting there.
I have no prejudice. I would start up with regular coils and oil capacitors. You know, one of the things I learned from these years of experimenting is that you cannot use ordinary electrolytic capacitors here. So for the ones you have that don't have the ability to get oil capacitors, you have to do plasma capacitors, I think. But the thing about this is parametric conversion. That is something, if you want to get further with this, I think this is something you have to read up on. In my opinion, you can choose whatever you want, but in my opinion, this is the way this circuit, the lower the losses, the better it is. And I think, to my understanding, you have some frequencies that is more favorable for the macro than others. And you have to find out when you go from the plasma and you go into ordinary current, then and you don't necessarily go into ordinary current in this circuit. You do it out here, but this is something I have to try out. I have some ideas and I have some experience, and I will see how to work it. But the basic idea is that you have to initiate it, and then you can have a pre-charged capacitor and you discharge it in this circuit. Then you push in a lot of energy, and you get an effect that this guy explains in 3 papers. When you do that, you start the oscillating, and because this feeds energy to this, you can compare it with a child in the swing, and you are pushing the child each time it comes near you. That is the equivalent of this circuit. The macro delivers the energy, and this oscillates. And as soon as you get an oscillation here, you can use the converter to make it to ordinary electricity.
So, Rick, so if the Tesla coil was nano-coated, is that what you're talking about?
Yeah.
Yes, yeah. Dude, man, this is crazy. Wow. Awesome. I love you, man.
A superconducting Tesla coil kind of scares the snot out of me.
Yeah, think about it. It could be really potent. Maybe that's the secret to get the Miles. Remember Dr. Miles and his broadcasting Tesla coil arrangements.
Hi, this is Mosfet Rashid. I want to jump in here a little bit. I have a little bit of experience with the plasma capacitors, and you might, since you have a background in analog electronics, you may be able to experiment on this aspect of it. The plasma capacitor itself has winding on top of it. So it's a capacitor plus the winding coil together. So you can, if you consider plasma capacitor as a battery with the power source within, which will be the GaNs, you can create an oscillator by changing the feedback into the capacitor. So like the split capacitor configuration is one such example. The trick is, how do you measure the frequency in the plasma domain? So that's what I don't know about. But I know how to carry out such an experiment, but I don't know how to measure the plasma frequency in the plasma area. So if somebody can suggest something along those lines, there are a lot of experiments I can myself do and suggest others to do it.
In theory, that little blue piece of pipe there with the 3 diodes in it, if you could tap off the drive of the diode with a high impedance frequency counter, you could actually come up with a way to measure the frequency of that, theoretically.
What we can do, we cannot measure the plasma. It's impossible, but we can see what is friendly to interact with. So if we replace this stuff or have made a circuit so that we can replace components or variate something, maybe something is variable, I don't know, depending on the practicality of it, then you can scan through a frequency range to see what is sympathetic to the macro.
Yeah, we wouldn't measure the plasma itself, only the effect of the plasma.
Yes. And that's what we need. That's what we go for. We want this ordinary electricity oscillation that we can convert. You know, if you put a resistor here, it's dead. That's a big no-no. No resistor here. Just to employ on the Tesla coils, if you have a Tesla coil here and a Tesla coil here, and you connect the two spheres, then due to the effect described in these papers, this will generate electricity. Input energy here, output energy here.
Yeah, that's been demonstrated in YouTube movies with the coils close together and so on. And I think, what's his name? Eric Dollard also has shown that with his
He's
experiments.
actually one of the, Eric Dollard is one of the few masters in Tesla technology, and because of that he has been hunted down several times and got all equipment destroyed.
And he talks about the longitudinal waves as being, as opposed to the transverse waves of radio transmission and so on. And that the true secret is in the longitudinal waves, which are essentially instantaneous. They're not limited by speed of light necessarily.
Maybe I could add something here if you're interested.
Sure, go ahead.
If you have an ordinary coil, one layer coil, wound on a coil former, so it's controlled, and you can use 0.5 millimeter wire and 15 millimeter form, and I think it's 39 windings. If you make such a coil, it resonates around 27 megahertz. And the things I intend to do, as you know, we cannot measure the plasma, but we know that due to the background noise that comes from the universe and all the electric stuff we have around us, there's a weak background noise. So if you have a spectrum analyzer and you have, actually, if you make this coil in a good quality and you have a frequency analyzer, that is a device that has a presentation where this is frequency and this is amplitude. And this is on the screen. And normally, if you have such an LC circuit, it will have no. If we have a function generator making a sinus tone, a clean sinus tone, it will be shown on this instrument as a pin, because it's a specific frequency of a specific amplitude. If you measure a circuit like the LC circuit, then you will probably get a curve like this with a kind of bandwidth in it. And the lower losses, the higher it will rise and the thinner it will get. If you have a coax wire, you know, normal coax wire, it has a shield outside and it has an inner conductor. If you remove, so you have maybe 5 or 10 centimeters without the shielding, and you put it near this coil and you let it sit, then after a minute or two, this coil, after you have touched it, it will begin self-resonating. And this is something well documented. Mr. Stifler did, and Dr. Stifler did, and that is that you have two resonance frequency.
Can I show y'all something and get a little bit of if this gives you an idea? I'd like to hear what y'all think about it.
Yeah.
Yes, sir. Yes, sir. It is. Oh, no. Okay. This produces like 2.6 kilohertz, something like that. It's yeah, well, it puts out a frequency.
Yeah, but it doesn't do it by itself. But you know, you have a speed controller, and there's an inverter in the speed controller, and it's a square wave excitation of the motor. It's exactly the same as in the device I shown, the electronic circuit, and that because
Yes.
but this is not the same as I'm speaking about here, to my best knowledge. You have two resonance frequencies when you have a coil. You have the ordinary, and now I'm using my old terms. I have the hot resonance and the cold resonance, or spatial resonance frequency. And in Mr. Keshe technology, this is, I don't remember the notation, but this is called spatial resonance frequency, the cold. And if you have a coil that is not so suitable as for radio frequency, you can do something else. You can add an additional coax wire from your frequency generator. This is symbolizing the coax cables. Then you feed a bit of energy to this one, and you make a sweep. And normally you will just have the background noise, but when you hit the resonance frequency, you get this, and then it continues on. This is a way to find the cold electricity resonance frequency of this coil. So this is the basic idea I want to employ here. I can feed it some ordinary electricity, and as Mr. Keshe says, it's very difficult to influence the plasma with ordinary electricity. But if you have an instrument capable of measuring down to minus 140 dB or something like that signal, that is very, very weak, then you see an effect. And this I will use to do the dimensioning of this circuit. And as I said, you cannot measure the plasma, but you can measure the effect on ordinary electricity. And in a way you get it here. You get ordinary electricity because as soon as you get the electrostatic effect in this capacitor, whatever it's an oil capacitor or plasma capacitor, you have some dielectrics, and in the plasma capacitor, to my understanding, you also have some energy generation in it, because if you use the CH3, so it feeds a bit of energy, and it raises the Q value of the circuit. You know, that's related to losses in the circuit. That's a smart way using ganses to raise the Q value of an oscillating circuit. So by varying these components and testing out with the frequency generator and the spectrum analyzer, I will try to identify a frequency that is compatible to the operation of the macro.
Mm-hmm.
And when I reach that point, and I can pre-charge a capacitor and discharge it and create the pulse, this circuit will oscillate forever if it's fed energy, and this feeds energy. So
And
I might be very wrong on this, but to my best understanding, this is the way. And as soon as you have this oscillation, you can convert it. And then you're done.
By the way, maybe not all of you are familiar with what the Japanese knowledge seekers are working right now.
I'm not aware of much because I use all my time in classes and
yeah. So on Facebook, you can find Mr. Tony Saito.
Yeah, but I'm not on Facebook. When I demonstrated one-wire lighting in 2007 or 8, it was, then I got attacked on the internet. I had my own company, I had my servers, and I have several PCs, and all got attacked and redirected, man in the middle.
So I understand. So if you isolate yourself from the outside, in that case you are safe, but you don't know whether you get the freedom or you are like in a jail. So
yeah, I know.
You have to find the balance of acceptable security and still some liberty. For instance, if you still want to access the social media networks, where there are tens of thousands of people interested in the same fields we are. In that case, you can consider just to separate a tablet or another computer which is isolated from the rest, and then you can.
Yeah, I have used air-gapped computers ever since 2007.
Yeah, one of the ways is to have a portable operating system on a USB key, and you boot the computer from there, and it doesn't write anything on the hard drive. Everything is in memory, and later it erases everything as you switch it off. Only leave it for antivirus.
I can add to this that I worked with computing for 35 years, and not to pull you down, but I have used several encrypted systems that run on the Tor network, and I use something that's called Tails, and I use that for communication on the internet. And then I have made an exception due to the Keshe Foundation that I have an ordinary computer now I'm using right now to speak with you, and it has nothing of value in it except for all the public stuff from the Keshe Foundation.
That's a very good thing to separate what you use for production that normally should not even connect to the internet unless you need to communicate by internet by secure ways. But there are computers for production, for your business, and separate for private and leisure. By the way, I wanted to share something because I was sure you didn't hear about. Mr. Tony Saito has posted in a Japanese cache-related group, and also he posted on Golden Age Games and other groups such kind of multivariable experiment where, let me magnify this, where he made many combinations of such a plasma capacitors. He made on a 6mm inner diameter. I think he used 18 turns of 1.6mm diameter wire and a central pin, and he wrapped there some paper or some foil, and here are the ganses which he used for paper, and whether with foil or without, with aluminum foil, with zinc foil, etc. So he made many combinations with nano-coated copper or pure copper, non-coated, and so on. And he made many measurements. Many measurements. He measured the capacitance, the voltage, inductance, resistance, etc. And what he found something interesting in the case of he used CH3, in that case the capacity and the inductance were increasing. And in a special combination, he achieved from those little coils of the plasma capacitor, he measured, I don't know how, 20, 40 microfarads, which seems to be huge.
Yeah.
So, but sure, this has to be replicated with other method of measurement to avoid measurement errors, but it's still something very interesting. Look at the right, he calculated the resonance frequencies of that.
Please repeat the last sentence.
So, in a combination of materials used for building the plasma capacitors, especially when he used only CH3 GaNs in combination with zinc or aluminum foil, he achieved very high, surprisingly high capacities, such as 20 microfarads or 40 microfarads.
May I comment on that?
Yes, of course, please.
When you have this circuit here.
Let me stop my share to see your screen.
When we have this very ordinary circuit, we have a coil, we have a capacitor. This, and it is fed this way, so we say it's a parallel. And you know, we have to feed it because it's not self-oscillated, because of losses.
Of course.
Yeah. What this circuit actually do is that when we are operating at the resonance frequency of the circuit, then the energy goes back and forth in this circuit.
Yes.
At one point in time, all the energy in the circuit is stored as a polarization in the dielectric in this capacitor.
Yes.
And in the next moment, all the energy is stored as a magnetic field in the coil.
Yes.
Right? And when we determine what is how many farads is this capacitor and how many millihenries is this coil,
yeah,
then this measurement is based on the amount. When you measure the capacitance in a circuit, you load it with a current and you see the voltage rise.
Yeah, you can calculate easily the resonance frequency, or you can design it by using the Thomson formula, if you know the parameters of the two components.
Yeah.
But then later you verify it because the ideal component is not the same as the real component.
No. But now I'm just trying to explain a basic principle, because when you have this capacitor, you put a current through it, and you get a voltage curve as a function of time. And based on this measurement, you say this capacitor is so many microfarads or millifarads, whatever. But what if you have a capacitor that generates energy itself? What if you add something to this guy?
That's our plasma capacitor.
Yeah, and when you add energy to it and you do a measurement, it seems like the capacitance is higher, right?
Yes, because it's producing energy. So this was my supposition regarding to the measurements. I observed that the jump in the measured capacity appeared when the voltage generated within the plasma capacitor reached over 0.65 volts, which is the opening voltage of the diodes, which are parts of the electronics of the instrument. So that's why I suggested to Mr. Saito to put in series with that plasma capacitor, a capacitor of known value, and in this way to obtain a galvanic separation to avoid that DC energy which is produced by the plasma capacitor to influence the functioning of the measurement instrument, and then he could calculate very easily calculate back with a simple formula of two series circuit of two capacitors in series. I don't know if he did that. For the moment, just I wanted to share as an inspiration, not to take it as it is, but as an inspiration to what kind of things are done, and maybe you get some ideas. So that's why I'm sharing again my screen. So the conclusions of Mr. Saito was that this would be the theoretical equivalent circuit of a Keshe capacitor.
Very nice.
Capacitance, it's a resistance, it is a inductance, etc.
Yeah.
You suggest that it is an inductance. It's got the coil built in, so it's all of the above and the battery. It's also, you're missing one thing, one vital thing out of this circuit that changes the whole thing into a receiver, which is the diode. And part of the circuitry of the Keshe capacitor is the nanocoating itself is a diode. It's built into the whole thing. So it's actually got the diode. And then you've got all the components of a crystal radio. If you hook up an antenna and ground, and you'd be able to tune in something with that circuitry, with just the plasma capacitor, it looks like.
Yeah. Yes, and you see what happened when he measured the DC voltage. He measured different in different direction. So this is the diode effect, you see?
Yeah. Mm-hmm. So we just have to hook up. All we need actually is a friggin' earphone. We need to listen to this thing and see what it's telling us. It's actually already broadcasting. And not to mention that one is actually making 55 hertz, which is what is exactly in between the 50 hertz of Europe and the 60 hertz of North America. It's right in the ballpark. It happens to be the one with the most capacity and the most change as well. That's great. Love it.
And you see, this is the key, because this guy has made some basic research illustrating what I was showing here with the LC circuit, because the plasma capacitor is the LC circuit actually. You see that?
Yes.
So by designing, now we are getting away from just picking some wire and picking some baking paper and some ganses and doing something. Now we are going to a step in this development that we know exactly what we do, the precise diameter, so many layers, and precisely this mixture of GaNs, and measure what do we get. Because
the key point is to measure.
Yeah. Because we cannot do it in any other way, because we cannot measure the plasma itself, but we can study the effect, because when he says a frequency, this is in ordinary electricity.
Yeah, we cannot measure the wind, but we can measure the effect of the wind, how fast it spins something, for instance.
And see, now there's two ways to do this. The fast way for me, because I can do this, then I don't care a shit about the frequency, as long as it is not above 100 kilohertz. I don't care, because I can.
Those from radio control will care. If you produce a frequency which will disturb some frequencies of the aviation, and it will interfere with the safety of landing of the airplanes, you will have some visitors. Yes,
but you know, I have worked with I have made an instrument for an aeroplane, and I spoke every day some time with an expert in radio emissions, how to design electronics so it doesn't emit any harmful energies to the surroundings that disturb other instruments. And I made this instrument so that it could pass the EC regulations. I have
Very
spent
good.
a year of my life on this, so I know what
I understand it's not easy. I remember when I worked at a factory which worked in research and development for such a plasma-assisted chemical vapor deposition equipment, and also some magnetron sputtering and so on. And then it took a hard time to bring the team of measurement and to create conditions to measure what is radiated out, etc. And sometimes you need a Faraday cage for such a proper measurement.
Yeah, but I also worked on a factory making electronics, and this guy was hired from a scientific institute in Denmark as a top expert, and I listened to his wisdom for 1 year. Every maybe 15 minutes after each time we had dinner, I spoke with this guy, and after he had done the job, he was headhunted for Cisco in California. So
that's a nice life experience, and to learn from such.
So I'm in the lucky situation that I know how to do this, because this converter will emit noise, but it can be shielded. And the noise that comes here, nobody can measure.
Yeah, let me tell a small anecdote. Just about a month or a month and a half ago, it happened to two knowledge seekers of Romania. They built together in the same lab 2 MeGREV units, one for one and the other for his friend. And they live at 4 kilometers distance each other. The MeGREVs were tuned to the same parameters.
Yeah.
So it was an interaction in between. And suddenly they had a visit from airport security. They're living near to the airport in Bucharest.
Yeah.
And the issue was that at the airport, at the radar, they had seen like there were a wall, a barrier. They saw nothing, so it was nothing visible in physicality, but the radar screen was showing a huge barrier, like a wall, between the 2 points, between the 2 houses. So they found nothing in the terrain, so they went to the origin point of that virtual barrier. They found him, and of course they had to move with the radar, with the mobile radar and so on. And they asked, well, what are you doing here, man? He explained, this is the MeGREV, this is for energy saving, whatever. Anyway, they took away his MeGREV unit. They borrowed it for a week or two. They studied, they searched, they found nothing, because it never produced the same effect. Probably it was a different location.
Yeah.
So they returned it finally, but they said to him, you know, you have to stop whatever you are doing, because either you have to move from this place or we have to move the airport.
I'm not in doubt what they would suggest as a solution.
And you have to remember what Mr. Keshe told about the defense applications of the MeGREV units, when you can create a complete barrier for electromagnetic waves in a certain area.
Yeah, that's
so
what
you can stop remote controlled rockets to be ever controlled if they enter into your zone, your protected zone. Mr. Keshe also had a similar experience. He said he was working in a lab in a big building. There were other companies there, of course, and at a moment he made some experience with 2 reactors. They were spinning sphere gas-based reactors, and somebody was knocking at the door. So please, we don't know what you do, but stop it, because we can't use our mobile phones and we can't use our Wi-Fi's.
That sounds very nice, because I have worked with electronics so many years that I'm oversensitive to it. That's also one of the reasons I stopped the experimentation, because
it would be so nice to create your own barrier oasis of peace, where you are not disturbed by the many electromagnetic fields and the noise which comes from the surroundings.
That could actually, if we could develop that, as a if a group of people in Keshe Foundation could develop a device, probably a very small one, that could do this. We could.
Yeah, Mr. Keshe explained how to make that. He explained in one of the public workshops.
Yeah, but if we build such a thing and we commercialize it, then we could raise a lot of money for the Ghana project.
Well, possible. So it's
Because
worth working on development of such a product. And by the way, remember also the words which Mr. Keshe told about 2 years ago. You want free energy, you get the technology, but probably you have to give up with your comfort of having Wi-Fi's and mobile phones.
No problem for me.
So you have to develop also other ways of telecommunications.
Yeah, but you know, I have a house in Sweden, and at that time I had some expensive measurement equipment to measure on Wi-Fi and mobile phone and all this. And the place I bought in Sweden has the lowest emission I've ever measured any place. When I measure in Copenhagen, the levels almost everywhere in the city is 10,000 times the level recommended by the German BAU.
I bet it's not as high as Shandor's place.
I don't have now at my hand the measuring instrument, it's in the other room, but I bought such a field, a cheap $10 instrument from China for measuring electric and magnetic fields. Jay is with us, he bought also the same model, so he can confirm if he has a microphone. And I live in a place where they have thousands of apartments in such a block houses, in concrete houses. Yeah. Everyone has cooking based on electric power, so it's 5 kilowatt consumer per house. So there are thousands of amps, and the cables the electric wires don't go through the metal pipe. So they are not screened. It means all they work like antennas and they are radiating. And in addition, I have 4 cell phone towers in a proximity of less than 100 meters around.
Oh.
In the house, if I start a mobile phone or a laptop or a tablet, it can detect at least 30 Wi-Fi networks with very strong signal, not to say about with weak signal. So when I did a measurement, I bought a measuring instrument with hope to use it for my Magrev experiments, and I cannot use unless I would use it in a Faraday cage. If I would spend huge money for some tens of thousands of dollars to make my apartment to be a Faraday cage, copper sieve is not so cheap, because the background is 900 volts per meter electric field, and over 10 microtesla the magnetic field. I have to move out of this district, out in the field for at least 500 meters far from the buildings to get a healthy radiation level.
If I were at your place, I would get ill immediately.
So no wonder why there are so many cancer cases in the surroundings and why people's life is short. It's no wonder. Of course, I would move, but I cannot.
Yeah, it requires a lot of money.
Yeah, my dream would be to live in a cottage where the next neighbor to be at an arrow shot distance. But that's not always possible.
Bow, the strong bow.
Of course, so I mean about 400, 500 meters with a Turkish bow or Hungarian bow, not with a long bow. Those are good 200 meters usually. But even 200 meters would be fine.
Well, maybe we should look more at creating an oasis within your own home kind of situation, because many of us, I mean, basically this is the same problem as being in space. You're going to have these intense fields, invading into your space in space if you don't have protection. We have protection of the atmosphere here, which is good for most of the cosmic rays and so on. But here we are creating our own cosmic rays and intense fields right inside of our own buildings. And if you can't move, then maybe there's a way to set up a field inside. Like a Faraday cage is one way. That's like a
I'd
what do
say
you
a
call that?
magnetic or
That's a
gravitational shielding better.
yeah. The Faraday cage is a matter level way of doing it. That's the old way of doing it. Maybe this shielding with a magnetic gravitational fields or plasma will be not only more effective but and more enjoyable perhaps, but cheaper as well. So this is something that's pretty serious because it's something we need on the spaceship. This is what is it's all about, is creating those fields, creating the fields.
Such a local oasis and mobile oasis would be the best. So something small that you can carry with you. And then you don't need the umbrella.
Like even NASA is talking about creating fields now. They're talking. There's the latest thing in the physics news and so on. The NASA news is they want to put a magnetic field in between the sun and Mars to protect Mars and allow Mars to create its own atmosphere.
Yeah, because now some men have the idea of colonization.
Yes.
They destroyed some continents, and they they decimated some people, and now they want to do with other planets as well. It's the bad habit.
Well, they want to rejuvenate the planet is the supposed goal, but and they want to colonize. Yeah, they want to have lots of people go to Mars and to have that, or to be on any planet that doesn't have an atmosphere, or to be on a spaceship that doesn't have an atmosphere. It's all the same problem. And if you think about it, that's how our atmosphere exists, is through the magnetic field of the Earth. Otherwise, we wouldn't have an atmosphere. That's what happened to Mars. It has no magnetic field in its structure. Therefore, it lost its atmosphere. It wasn't able to protect the from the rays coming in, and it destroyed its atmosphere. So if Earth was to lose its magnetic field, which it is weakening, and it does, flip and change every so many thousands of years and whatnot, then we would also lose our atmosphere, not all at once, but gradually as the sun's rays destroy everything. So that's how we would create it in a spaceship, and that's how it would be created in your space inside your apartment, essentially. It's the same principles involved, magnetic fields.
So unless some man will be able finally to learn how to manipulate directly the fields without to use via like a matter state intermediary components, still we have to rely on making such an independent plasma source or independent power source or whatever what Eric has shown us, these ideas about using such a resonance circuit to tune it and so on. And maybe we can learn also from Tony Saito's measurements, at least that we have to find our ways how to measure and to tune up and to follow the purpose and to start producing applications. With the knowledge we have given up to now, I think we have to work a lot for the next 200 years if we have so many.
Yeah. Thank you for showing that, by the way. It was the exact question that was on my mind the last couple of weeks, was about plasma capacitors and what the actual capacitance is. And I've just got a meter a few months ago that can measure capacitance. My latest electric meter, my voltmeter has a capacitance function. I was going to use that on some coils, but I have to make them and measure them and so on. It's good to have that chart. It's very handy, and it's good baseline to start with there.
So as a suggestion, which I may have, I understand that these capacimeters work in the way that they have a high frequency generator. They have an AC generator of some kilohertz there, depends on the model. Some have a variable frequency that you can choose at what frequency you want to test the capacitors. Those are the most expensive. Those are not $20, they are over $200 or more. So you can choose your instrument, but to avoid the instrument to be disturbed in its function by the small virtual battery, DC battery, which is the plasma capacitor, you can connect the plasma capacitor in series with known value capacitor. For instance, you take one from microwave, it's not polarized, it's about 1 microfarad, the value is written, you can measure it, and then you measure the capacity of the circuit of this one in series with the plasma capacitor, and with a simple formula you can calculate back how much is the capacity only to this one without allowing the DC to go through the capacitor, so the DC will not reach at all your instrument. So if you look at the detailed electronic schematics of the capacimeter, you will find some diodes there. And those diodes can be disturbed very much if you inject DC voltage. So such a LCR meter is not designed, for measuring something which is powered. It's for passive components, and the plasma capacitor is not a passive component, it's a very active one. It generates electricity.
Yeah, if you look at, I put a link there from the gigahertz on the chat now. It runs very fast, so maybe I should just pull it once more, so you don't have to search for it. In the picture to the left, you see the equipment I bought, and it was terrifying to see the effects of this. There was a guy in Sweden. I was measuring at his house, and he had a router right next to his bed. And he had an operation for cancer 1 year ago, and it was still standing there, and said to him, if you don't want to get operated once more, get it away. Turn it off when you don't use it.
Yeah, it's a very important detail. By the way, I have my router switched off in the night, but all the neighbors have switched it on, and a neighbor has it just behind my wall where I sleep.
Yeah.
And with routers,
you can get paint that can shield. It is expensive, but you can buy some paint that reduces the radiation quite a lot.
Yeah, and actually, the routers are set up when they install them, or when they give them to you or send them to you in the mail, like for cable companies and so on. They're set up to broadcast your regular what do you call it, Wi-Fi signal right out of the box. But if you're not using Wi-Fi and you hook up your computer directly with a cable, with just a what do you call it, the Ethernet cable, then you don't have to use the Wi-Fi, and you can actually go into your router and manually turn off the Wi-Fi function, so it's no longer broadcasting. I can hear. I've set up my crystal radio setup and as a detector, and I've actually done a video on it. You can hear the signal that comes out of a router, and it's about a 10 hertz pulse that comes out. Sounds like a woodpecker, kind of like dot, 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 and a really intense, it's kind of like a square wave type pulse that comes out. And it's also in waves. In other words, it's in a series of spheres from the router. It varies in amplitude. It's just got null places and then intense and null and intense and null and intense, depending on how far away from the router you are. So you could be sitting, in my case, in a intense point, and another foot away be in a null point, and so on. So it's a pretty it's an important subject, actually.
Yeah, so what I told, a better measuring instrument, it's about a couple of hundreds of dollars. And if you want to cover all the range for low frequency and high frequency already, you have to open your purse pretty nicely. Of course, there are better instruments.
They work very well, and they are quite precise.
Yeah, for that money, it's an expectation. They are very high quality products.
They are good products, and as Mr. Keshe said, that the Germans are a people that is suppressed very hardly by the Jewish community, and they pay still for Second World War lies, and but they have an extraordinary technical skills with all applications. It's amazing. If you want to get some quality material within engineering, and so the Germans are delivering that.
Okay, well, we're up to 4.5 hours here plus, so I'm wondering if we should maybe think about shutting things down. Really interesting stuff coming up here, and I think we have some meat to go on and some experiments to run and all kinds of things to think about here. As Doug says, the perfect oasis system is within us. Good point.
Yes, and what I like about your lessons, Rick, I'm not here very often because you also have to show something. I'm not the type of guy that just likes socializing a lot. It's nice to talk, and I can do that, but normally I prefer to do something. And when I have something to show, I will pop up again. And what I like and what I am very thankful for is when, as a newbie within the plasma technology, I'm very thankful that you and John and others and Sandor and a lot of other people come with advice, so I don't have to jump all the potholes on the road that I can, because we haven't much time. Of course, I have to do a learning like Mr. Keshe wants us all to have, but the way that we can help each other and to avoid the worst time wasters, that is very, very positive.
Yeah, that's right. Yep, because even the veterans can make mistakes for years, and getting trained into one way of doing things and think that it's correct, and that's happened a lot of times lately. Or Mr. Keshe has had to correct people, and even the factories that are doing things and so on. This is part of the process that we have to learn to keep up the communications and keep connecting with each other. Hi, Doug. I'm going to try to get you... There, I got your picture finally on the video here.
How good is that?
Is this the perfect oasis system?
Yep. It's working for me.
Right on. Good vibes. That helps. Shandor's
That's why some people are holding their head in between their palms.
Yeah, I guess that works too.
By the way,
I don't know what that was. Was that interference there? So there's
And by the
Shandor's
way,
GANs.
yeah, last evening I entered very late in the UK knowledge seekers meeting, and I thrown some GANs, and after that, after I steered the GANs, I put it on the table. You will find the records, maybe they will post that one publicly. But you see, here is a CH3 GANs, here is a CO2 GANs, and you see after it settled, it didn't settle straight like it should be by gravitation, but here it's higher, here is lower. It's like the CH3 away.
Yeah, it's peculiar, isn't it?
So after 12 hours, the position is still same. I didn't disturb it.
Huh.
So you can see the real power of the fields. There is an interaction at distance. Shall I steer it now?
Be nice to reposition it in different places and see if it does it again in a similar way.
Yeah. So here is the entire setup. So I have here my CH3 box. Copper plate is on the right, iron in the middle, and zinc is at the end. Here is the CH3 GANs, and here is the CO2 GANs, and here behind I have another similar. So I put it and I steer it well, and I put it on the other side. So I will see it later when it settles how it will be.
Mm-hmm. Okay.
But you see, the effect is still there.
Yes, interesting. Okay, well, we'll see if we can correlate that with somebody else's GANs experiments. Thank you, Shandor. Okay.
With my greatest pleasure.
Any other last-minute additions before we sign off here?
And our greatest pleasure, Sandor. Thank you.
Is there anybody I missed getting here that wanted to say anything? All right. Well, I think we probably should close off for now and call it a day or a night or whatever they say out in the universe where they don't have day and night. Think about that. What would you say in space? You wouldn't say good night or having a good day.
Great answer, Rick.
Pardon me?
Great, thanks for your exceptional activity. Since so many years, you are doing every week this Keshe Plasma Reactor Group meeting.
Yes,
it's priceless.
It's been a long time now.
Have a good time.
Yeah,
Bon voyage. Bon voyage.
The thanks go the other direction, you know. Maybe I shared a bit, but I got so much back. It's the principle of the plasma. So thank you all.
Excellent.
Thank you everybody for contributing, because that's what makes this group. If it wasn't for contributors, then I wouldn't have much to show in the last while. All my stuff's breaking.
Have you got heating now, Rick?
Pardon me? I've got heating, but pardon me? Heating?
Yeah, have you put the Ganses in your room to heat you?
Well, I've got Ganses around, and I've got nanomaterials and coils and stuff kind of all around. And I wonder if it could be a lot colder without that stuff, perhaps. But I'm still needing electric heat and propane heat to keep me warm here. This is an especially cold year. I'm in Canada, and you think, Canada's cold anyway, but I happen to be in the warmest part of Canada, And normally it doesn't even snow here, except for once every few years. But this year it's decided to snow probably a dozen times so far, and it's, you know, kind of unnerving. It's into March and it just snowed today again. This is very, very unusual for this area, and a little extra cold. I've got my, you know, sweater on here. So yeah, it's
You must do something for the next winter so you don't have to sit freezing there.
well, it's true. We should know by now, and Mr. Keshe has talked about, and we've talked about ways of creating warmth without having to heat all the air and everything around us. Creating the warmth, and the feeling of warmth is all we want. Basically, we want to feel, comfortable and at a temperature that feels normal to us. So if that's done through some way that's different
According
than
to
just
what
heating the air.
age?
Maybe I should share one thing more. Very fast.
Okay, Eric, go for it. You're on a roll.
See, this is the temperature of an inner wall in my house.
Okay.
And this is the temperature of an outer wall. This is the temperature of the floor. And this is the temperature of the roof, or the top of the room. I have never seen such small differences.
It's very small, yes.
An outer wall is typically 2 degrees colder than the room, inner wall.
Mm-hmm.
It's not anymore. You should do a little work on that, Rick.
Well, what do you attribute that to?
Yeah, but you have probably seen Eva's plates on the window, and I actually got a set of plates with me home when I visited her, and then there's this small bags. This is, can you see it?
Yeah, this is zinc oxide heat.
Yeah, I have this welder for plastic bags, and then the principle is to have the 4 basic ganses and a few drops of each gans in each of the 3 other ganses in the corners of the room. So you have the 4 basic ganses, 1 in each corner, and then you have a drop from the 3 other corners inside here. Then you get an interaction with the nano-coated plates connected with a nano wire. And as far, my wife was not that happy because because I had to experiment. So I turned off the heat. And it was -5 degrees outside. And when I turned off the heat, it seemed like it stabilized about 15 to 16 degrees Celsius. But it was cold, and she didn't like it, so I turned on the heat. But what I can say, if I have a measurement at the top of my radiator, it is 38 degrees, and that's not much. I normally have much warmer radiators to keep warm. So I expect a reduction in the bill. That was just what I wanted to show you, because you sit there and have a cold, and you don't need have a welder to do this. You can just have a zip bag and put in the GANS water. I think you have everything you need just to make 4 bags and a drop from each of the bags in, and some nano-coated materials, and then you are a lot better in position heating-wise than you are right now.
Good point. Yep. Could be.
And what you do is And what you do is I have been instructed to have the order of the stuff this way, and CH3. And this is your room.
Okay.
I just thought I would share because I don't like to see you sitting there.
Well, no, I just had my heat turned off, and I just used my remote control to turn it back on a few minutes ago, and it takes a while to warm up for the propane furnace to kick in.
Yeah.
So I've been sitting here for a couple of hours with the heat off and not noticing, and my legs got cold, and suddenly, oops, I gotta go turn the heat on. I forgot. So yeah, but thanks for that. That's that could be.
And you could do one thing more if you are alone. Then you have to have some. The last thing I was thinking about is Mr. Keshe says we have to add some amino acid to the reactors in order to control the spaceship.
Mm-hmm.
And Caroline said you have to control the heat. In your house, you just have to tell the gases, make me happy, make it warm here. And then it should work. But then my thought was, if that is what is required, then I need some amino acid into the 4 bags also.
Mm-hmm.
So as I have not made the gases myself, and I'm here all the time, I just put in 2 of the bags until now a drop of blood.
Mm-hmm.
It helped a bit. So I'm gradually trying to get this heating system going 100%.
Good for you. You're hitting the technology on all angles here. It's great.
I just try to improve my life and save some money. Because when you give your butt to Mr. Keshe, it's a problem earning money.
Yeah, that's the thing, eh? With you.
Thank you very much. Now I'll try to keep quiet so you can close down.
Well, I appreciate your input, Eric. Thank you very much for showing up and being there. Alrighty, so
I have another suggestion about heating and cooling. It's slightly different. It's along the line of moving your finger using your thoughts. So you can do a similar experiments in heating your body. Just closing your eyes, and you can figure out by just feeling that you want to heat your body and feel which part of your brain is working at that time. And similarly, you can do the same experiment using thoughts of cooling, and you'll see that different parts of the brain become active. And in that way, that's another way of cooling locally. Of course, it works very well. I've tried it several times, and it's actually surprisingly well.
It works for the.
Where I live, it's very humid, so I can stop myself from sweating by that process.
It works for the Tibetan monks who are who have to put a wet sheet around themselves and dry it out with their body heat in freezing temperatures, and that's one of their assignments apparently, to learn how to control that body heat function.
Yes,
but Mr. Keshe's technique is much easier. I have actually done some meditation experiments, but this is way easier to do.
Yeah.
What did you say you did to do that?
You focus on warming up your body by your thought, and watch where in your brain it's happened.
Yeah, okay.
It's different location depending on different set of location, not one location as such, but set of locations. And then you just focus on those locations and you'll feel cooler. Similarly, you can heat up, and it's different location for the 2 processes.
Yes, that's what I did in the long hours as a programmer. When I worked all night, then I got cold on the legs, but then I could heat it up using this technique. So it works, I can confirm that.
Thank you.
Very good, guys. Thank you for those helpful hints to get through the cold Canadian winter. Or whatever country you happen to be in that's cold. A lot of them out there nowadays. In spite of global warming, things are freezing. That's the way it goes. That's the irony of the universe, right there in a nutshell. Okay, I'm going to stop philosophizing and pontificating and whatever other words, and stop talking because it's now 3 in the morning here and I'm getting a little tired. So I think I'm going to end things. So thank you everybody for attending as usual and presenting stuff and asking questions and the whole thing. Thank you very much. Hope Jay, I hope you got everything answered there. You had a couple of questions and I think they sort of got sorted out.
Thanks, Rick.
All right, good. And yeah, so let's call it a night, a day, call it what you will. I'll call it over for now. I'll stop the live stream.